Okay, everyone. Good morning and welcome to Flutter Festival London. Thanks for joining us. I know it's early on a Saturday morning, and we're all still trying to wake up. I know I am trying to wake up still. So we're gonna have a range of talks today as well as workshops. And again, welcome. I'm Jen Ashley. I'm one of the leads for Google Developer Group in London, and I've got other leads here with me. So I'm just going to ask each one of them to introduce themselves. And we're also partnered up with Flutter London. So we have Simon here, and again, he's going to introduce himself. So maybe Simon, you can come up first.
Oh, goodness me. Hello, I'm co-organizer of Flutter London. We will be starting the meetups again, hopefully soon, but we'll have to do with this today. And thank you for everyone online that's watching.
Sumith. Yeah. So I'm also part of GDG London, big part of the community, guys, and I think we have full pack agenda for you today. So go through all these nice talks in this glorious sunny day. I know it's beautiful outside, but it will be fun here also. So I'm gonna come.
Do you wanna? Okay, I just want to mention that so we printed the program yesterday morning, but we had to change the schedule last night. It's not a major change, but some talks have moved around. So if you can just refer to the online schedule on the website, flutterfestival.com, and just click on schedule, you'll have the most up-to-date schedule there for today. So we have Renuka next.
Hi everyone, I'm Renuka Kelkar. I'm also co-organizer for GDG London.
Hi, I'm Mamta Gilani. I'm also one of the co-organizers for GDG London. Happy to see you guys here in person and hope you will enjoy the sessions. Thank you.
Hi everyone, my name is Jai. I'm also lead organizer for GDG London. It's great to see everybody today. If you have any questions, please reach out to me and I'll catch you in the breakout. Thank you.
So we have one workshop that's also going to start with Ann Butterworth. They're actually heading to the room now on the second floor, room 6. So if anyone wants to join that, feel free. But for now, we're going to start with the first talk from Renuka. Thanks, everyone.
Hi everyone, I'm Renuka. Thanks for joining this session. Thanks for coming for the Flutter Festival London. So let me give you something a little bit about myself. I am a Google developer expert for Flutter. I am the founder of the Tech Power Girls community, and I am the Flutter developer at Altaflora. So today's my topic is about. Before that, I just want to give a little bit about my initiative called the Tech Power Girls. So the Tech Power Girls is a tech community specially created for the women who are having 5+ years of gap in their IT career. And we help them to learn Flutter app development, and we train them on that, and we help them to, they can come back to the job market. So today's topic is all about the Slivers. So what are the Slivers? I think in the community there is a statement going on that there is a fear of the sliver. So I think don't need to be scared about the slivers. Slivers are really cool, and we will see today about the slivers, and we will go through each and every section of the slivers. And I think after finishing this session, you also love the slivers basically. So sliver is nothing but it's a scrollable area that you can be customized basically. So what are why we need sliver basically? So if you can see any e-commerce app or the app where you want to add so many like a list inside there are different lists, and you want to add some grid view inside your page, and when problem occurs, then first list will scroll up, and when it reaches to the top, it will not give you the chance to scroll down again. So that kind of scenario where we really need the slivers basically, because we need to customize our scrolling effect. So these are the scenario, but before that we should understand how we render the normal widget inside the Flutter. So normally what happened when you render your normal widget inside Flutter, so normally we have like a box constraint, and it is using the box renderer basically, and box constraint give the height, width, minimum height and maximum height kind of things. It will go to the renderer and it will paint that object on the screen with the particular size, whatever size we have given them. So let's consider if we are wrapping like our container with the center widget. So what will happen? It will tell the renderer that okay, I need to paint this object at the center of the screen. So that's how it will normally render the objects with the box renderer. But when the problem occurs, when you want to render the moving object, the renderer doesn't know like where to exactly the render or paint that object on the mobile screen. So that time the slivers will come in the picture. So it will take the sliver constraints and it will render to the renderer, and it will the sliver geometry will give the exact location where it should be paint, what size it should be paint, and that's how it will work basically. So this is the like a thing going behind the scene basically. So this is how the slivers works. So when you want to use the slivers and custom scroll view always go hand in hand. As we are saying that sliver is like a custom scrolling effect, then we need to use the custom scroll view. So whenever you want to use the sliver, you should use the wrap your widget with the custom scroll view, and it is always have like when you use the custom scroll view, you always use the child as the slivers. So just like when we use like a list view or the grid view, that time we are using like a children's, right? So that's how we can see here that custom scroll we always go with the slivers. And there is one more requirement. When you use the custom scroll view or when you use the slivers, the object or element inside that slivers, it should be like a sliver object. So like you can see here the sliver app bar, sliver list or sliver grid list kind of thing. So if you are thinking that, okay, I'm using the custom scroll view, I'm using a sliver, and I can put the app bar inside that, then it will definitely show you the error. So let's go and we will see what is the next. So, here is a sliver padding. So what will happen? It is like outside is the sliver and inside is the sliver. So as I mentioned that when you use the sliver, you should use the sliver widgets. And when you use the sliver widget, normally we want to have some kind of padding to our widgets, right? So that time you cannot use the normal padding. You need to have like a sliver padding for that. So this is how we can use the sliver padding for the sliver widgets actually. So the next slide will be the like a sliver list. Okay, so it is the same way how we use the list or list view builder. Like you can use the sliver child list delegate for the normal sliver list. And if you want to use the list view builder kind of things, like you want to create a dynamic list view builder, so you can use the sliver child delegate dot builder, like a child builder delegate for that. So you can use this sliver list inside your app. The same way the sliver grid, it will work the same as normal grid works in normal widgets. So this is how you can use inside. You can also give the fixed cross account, which is similar to the normal we have given to the grid view. The next thing is that, as I mentioned, that we need to use all the time the sliver widgets, right? But sometimes I want to use my own kind of widgets, like a container and the text and other thing, and how I can incorporate with that inside my app. So here is the widget which is used for the sliver to box adapter. So inside using this widget, you can add normal container or normal text or any other normal widget inside your sliver widget. So this is again like a because we are normally get used to with the normal widget. So I think this is really good for us to use this. The next thing is that a sliver app bar. So as I say that the sliver app bar is actually the same as a normal our app bar, but sliver app bar gives the more control on your app bar. Basically, you will get a more fancy effects with that. You can have more property to that. So normal app bar will have like a title property, leading, action, all this stuff. And this is already included for the sliver app bar as well. But there is some more property for the sliver app bar. We will go through one by one for this. Okay, so the first property is like an expanded height. So how it works? So here is an expanded height. So when you want to have like a scrolling effect, then you can have like a, when you go scroll down, that time you can have the height, you can increase the height of your sliver app bar. So these property will decide that now I have given as a 300 height to this sliver app bar. You can decide at how much height you want when you scroll down to your sliver app bar. So that property help you to do that basically. Second property is a pinned. So normally nowadays everyone wants to like a sticky header because now Flutter is working. You are using the Flutter for the web as well, right? And web you always see that there is a sticky header or sticky top navigation bar in the apps, right? So this kind of effect, if you want to have some navigation on the top and you want all the time that navigation on sit at the top of your app, so this kind of the pin property will give you how much when you want to scroll up, it should pin the your sliver app bar basically. Then it's a floating property. So you can see here in the animation, when you if you don't want to pin your app bar, then you can use the floating property of that. So you can scroll up, it will scroll up your app bar, and when you scroll down, it will come down. Then the second property is a snap. So when you scroll down, it's a directly, you can see here, when you scroll down, it will directly see your scroll app bar at the same time. And if you have just floating property, it will gradually come down to your scroll bar. So this is the difference between the snap property and the floating properties. The next property is very much like interested for me that when you want, because you normally not want the like a plain colors app bar or all this thing. You want to like do some customization for that. So that reason that this flexible space property, which will help you a lot, which will have a title property. So here I have given that welcome to space, that is a title we have given here. And then you can add some background effects like a background image to that. So it will give you the like you can see here how it works. It will have like a collapsible mode as well. So you can use that property. You can see here there is a mode called a parallax. So it will show the parallax effect when you're scrolling up. So you can see here when I scroll up in this video, so you can see that image is little bit like a parallax kind of thing. So what is a parallax effect? So the scrolling speed of that image is different from the scrolling speed of our normal widget. So it will give you that kind of effect, like a parallax effect. Again, there is one more property called a stretch mode. So when you scroll down, that time you will find some white color space because the image is, you have given the image like a expanded height like a 300, and then you want to, when you scroll down, it will take it will not take the whole space. There is a white gap between the image and the widget underneath that. So this stretch property will help you to stretch the image, and it will have some more properties like a blur background, then fade title, and the stretch mode. So you can see here there are three different properties you can set with this stretch mode. So the next one is like a sliver fixed extended list. what happened if you are using like a list view builder, and if you know that you have all the list atom with the same height, so that time you can use this widget where you can mention, you don't need to mention each and every container that, okay, this is a height of 200. So you have this property like atom extents, and where you can give the height of the container which will take for all each elements inside that. So this is one property, we can use it. The next thing is like a sliver fill viewport. So normally you can see this is for the page view. You can use this as a page view builder, page view, where it will take the whole size of your viewport. So if you want this kind of effect, basically this sliver normally is using for the list view, grid view, page view, but we don't know that is the slivers. That we normally know that is a list view or grid view or page view. So the next property is like a widget is sliver fill remaining. So whenever you want to fill something, whatever the area remaining on the screen, that time you can use the sliver fill remaining widget, and you can give and customize that widget with the colors and the other property. So this is the screen is very much interesting. When I thought about the giving a talk at this event, and I'm very much inspired with this YouTuber. He's also a Flutter GDE, and he is creating a really amazing effect of like a transition effect for the web app or mobile app. And I'm very much love to that kind of thing, because I have a background of like a 3D animation in my previous thing. So I am just going through his tutorials and his work. So that time I got to know that, oh, these kind of effects, it's not going using with the animator builder or animation kind of thing widgets. So that's how I got to know about, oh, you can do the really cool thing with the slivers. So I think you can go and check his videos as well. It's very amazing. So you can see here, you can see this transition effects. So you can see the sliver when it is going up, then you can have some transition effect. When you click here, it will have some animation while scrolling. So this kind of effect you can easily create with the slivers. So for that, so this is the one widget, sliver persistent header. So as of now, we have seen about the sliver app bar. So, but they have their own properties. But if I want to create my own, if I want to create my and customize my own sliver app bar, so this is the widget behind the creating a sliver app bar. So sliver persistent header will give you the property it will have the property of delegate, and then you can pass your own sliver inside that. And it will have two properties like a max extent and max minimum extent. So I will show you how it will go. Okay, so it will give the override the three things like you can have like a string offset and overlap content and context. So what is a string offset? So string offset is a distance from the maximum extent and minimum extent. And the overlap content is that if there is any other sliver rending behind the another one, so that will give us the overlap constant. So as I all shown you all these things, and sometimes you feel that, oh, there is so much like so much things I have to do that. So there is a one package called sliver header delegate. You can use this package. It will take care of everything. You can just set up your values basically. You don't need to take care of all this stuff basically. So I will tell you what kind of animation you can go through with. It's a very easy one. So first thing is fade in animation. Just like a normal sliver app bar, there is a fade in animation going on. So here I have created one variable which is a progress, which will have like a free shrink offset divided by the maximum height extent. And where you can see here the opacity I have given, and I have given the 1 minus the progress. So eventually first time it will have the opacity like a 1, where you can see the whole image, and slowly while you are scrolling, like a progress is a shrink offset divided by max extent. So it will slowly it will fade it actually. So this kind of effect you can create easily with the slivers. Second is like a zoom in animation kind of thing. So you can do the same thing here, where you can see here is a one method, like a one function called that, and you can use that, and you can give the two different mode. Like you can see here I have given two different colors and two different sizes for the text. So this is how you can create this effect very easily. And third thing is that you can do some animation related to that. So I'll just use the transform.rotate, and I've just given the vector.radiance, and I have given the progress as the parameter to that. So that's how when we scroll up, so it will do the rotation of 360 of that animation. So this is how it works basically. There are many more sliver widgets available: sliver opacity, sliver animated opacity, then sliver list. There is one more sliver animated list as well. So which will give you the, when you use the add or remove the list from that list, it will give some animation before that. So you can see there is a transition going on. So there are some packages available on the pop.dev for to use some kind of slivers effects. So the sliver tool, reorderable list, and auto animated. So these are the three. There are more as well, but I have just keep it like a 3-1. So you can go and check with this as well. You can get more cool effects for your next app. So this is all about the slivers. I hope you have got a really good understanding about the slivers. So if you have any questions related to this, and I think you should try next time the slivers in your next app.
Can you show us the previous slide, the one with the libraries?
Yeah. There are more packages available. Because sometimes we don't want like a simple kind of app. We want some transition, some kind of effects, right? And it's very handy to do that.
Sorry.
Yeah.
Can I ask, have you tried the reorderable package? So you can change order of the items, right?
Yes. So if it is use the reorderable list kind of thing, then you can change the item of the index of that list item basically.
Yes. Okay. Right. And do you know if then we need item key ID in order to keep the order and keep the keys of the items on the list?
I haven't tried that, but I think so that you can do that with that. Basically, you can use the draggable kind of functionality with that. You can just drag and drop to change the order.
We'll look into that. Thanks.
So, yeah, I'm done.
So we'll have a quick intermission, I think. 5 minutes. Are you good to go? Yeah. Oh, okay. Well, if you want to say, you good? Yeah. All right. Okay. We'll get. If you want to grab yourself a quick something and come back, that's fine. But it will just a minute.
No, I don't. Anyway, we don't want this. The best part is showcasing your products to using the and then they're going to be
You want to check on?
No, on the stream. One far in the area. Yeah. Yeah. That's not helpful. So you can even take a little bit of time if you want. And understand this whole thing this week. You can take you don't need the lecture.
It's like a TV remote.
Okay, we're going to go for the second talk of the day. Martin, thank you for coming. And Martin Pereira from Sony for us to talk about Codemagic and Flutterflow. So thank you.
Hi everyone, my name is Martin. I'm CEO at Codemagic, and today I'm going to talk to you about how we work together with the Flutterflow team to build this Codemagic Flutterflow integration. Because I think usually when I speak to some partners or some customers, then everybody thinks this DevOps and CI/CD stuff, it's really, really complicated. Like, how would you build some kind of integration between a no-code product and the CI/CD pipeline so you can suddenly start publishing applications to the app stores under the user's own accounts? This seems quite complicated. People weren't sure how it works, but if you actually start to think about it, it's not really that complicated. So hopefully I'll show you that. Has anybody used Flutterflow or Codemagic here? Yeah. Okay, so not everybody. So some background. Codemagic is the CI/CD product, and we are specifically good for Flutter apps. And Flutterflow is this no-code app that you can build Flutter applications with. Okay. So demo time. So this is what Flutterflow looks like. You can build like your applications, you can use different widgets and components. And this is some example, like a Flutter Festival and a love button. So if you love Flutter Festival, you can press it. And how this works is that once you build the application, you can preview it and also publish it to the stores. So what's necessary to do that in Flutterflow is that you should go to Okay. So you should upload the launcher icon, and then under deployments, you should set up your issuer ID, key ID, and app ID, and create a API key from the App Store connector. And in order to do that, you need to have Apple Developer Program license. They have some good documentation about this as well. Okay. So try to put down some requirements, what was necessary for the Flutterflow team, and something that we had to start thinking about. So first of all, they need a way to build and publish applications. And how you can do that is through YAML configurations. So you can create a standard YAML file that says how you should build and publish the application. I'll show you what that looks like. So this is what it looks like. It's really nothing special. So if you're familiar with YAML files, you have a workflows section, and you have a workflow name. Then you select which instance type you're using, your environment, in this case, your Flutter version, Xcode version, and Pods version. And then you can start writing your scripts. So the scripts define what your workflow does. And in this case, what Flutterflow is doing is it's setting up a keychain. And this is ubiquitous, so you can use that same script across all different apps that you build in Flutterflow. Then it's something what we provide, and this is what everybody can use, is that we have this Codemagic CLI tools. And within that tools, we have this command called App Store Connect and fetch signing files. So what this actually does is it uses our CLI tools, which is basically a wrapper around App Store Connect API. And we are fetching the provisioning profiles, the developer certificates, or distribution certificates for a given bundle ID, and you just define like the type that you want. In this case, since we're publishing, we need the distribution certificates. Again, the exact same command can be used for any apps that are built on Flutterflow. Then you need to add those certificates and set up your Xcode project. For that, we already have some CLI tools that are open sourced, and you just do Xcode project use profiles. And what this does is it sets up your Xcode project for code signing in a CI machine. Then you get your Flutter packages, and you build the IPA. So when you're building the IPA, then this is the binary that gets published to the App Store. So what this cool thing that they also do is they use the same App Store Connect command that I mentioned before, and they get the latest test flight build number that's available in App Store, so that you're always incrementing the build when you're publishing it. So this can make sure that whenever somebody is building an app on Flutterflow and they want to publish it, then you don't get the error message saying that you need to always increment the build by 1. So this can be done automatically. Yeah. Then that's it. That's as simple as it is. So now we have a build configuration that is publishing to the App Store. Right? Makes sense? Cool. So what else do we need? Then you need a way to trigger this build. And in order to trigger it, you're triggering it from Flutterflow. So if you want to trigger something from Flutterflow, you can't use like webhooks, for example, because you need to use an API call. So whenever somebody presses the button publish to App Store, you need to trigger the build on Codemagic. So then we're going to use the Codemagic REST API for this. And the REST API that we have, it's available here. You can check it out from the docs. And so whenever you want to start a new build, all you need to do is get your API token. You have optional parameters that you can pass, and you can start a new build. So this is what they do as well. I'll drive a little bit away from this Flutterflow example because I've set up my own example as well. So I'll show you how this works. Because what makes it complicated a little bit is that if you think about it, then each application in Flutterflow is a little bit special, and you don't want to store your secrets in your Git. So whenever you're starting a build, you need to pass environment variables that contain your secrets, for example, and so that you don't expose them in anywhere other than where it's necessary. Keep them secure. Okay. So for this demo, if you want to later see what is happening, I'm using this Codemagic CI/CD white label demo project. And in this project, it is basically this application. This one. I don't know if you can see it. Anyway, it's a basic app. And what is important there is that you have like a dev flavor and a prod flavor. And what I've done is I've created this API call. So I want to start the new build for a specific app, for a specific workflow, it runs on a branch, and I want to pass in some environment variables. In this case, I'm passing in the App Store ID, the bundle ID, Xcode scheme, the entry point, client ID in case there is one, and my App Store credentials, which are encrypted. Yeah. So let's run it and pray that it works. Okay, it works, and then I get the build ID. So now when you're Flutterflow, what you might want to do is, as soon as Codemagic, you start the build, Codemagic returns the build ID, you want to show it to the user as well that the build was started. So then you can do something like this, which is get the build status. Yeah, you can see over here, there's the iOS release workflow, and the status is preparing. So again, still preparing. And if you go to Codemagic, you should be able to see this build as well. There it is. Yeah. So it's running. So what we've done here is we've showed that you can start builds from any server using Codemagic REST API and pass in some environment variables. Okay. Then one thing that if you're trying to do this at home or if you want to follow along, some tip is that you can just put the API key in your sudo nano so that you don't need to use it every time or define it every time. And where you can find this API key is in Codemagic. You can go to your user settings and you have the REST API key over here. I'm not going to show it here.
That'll do that.
Okay. We showed how to pass environment variables. Then, in Flutterflow's case, what they're doing is they're passing the environment variables through the API call directly. But if you want, and what some other customers are doing, like DraftBit, for example, or we have some other customers as well, is that they want to authenticate against some CMS system and pass a client ID. So if you pass the client ID and you store some secret variable within Codemagic web app, then you can authenticate against your CMS system and then fetch some assets. So this is what I have done over here. So what this workflow does is, that's the one that I just started, is that the first thing that I do is I get the assets from AWS S3 bucket. And once I get them, then I will replace the hero picture in the app itself. So this is what the S3 bucket looks like. So I have these two files here. And then I'm just putting this picture there. Yeah. The good thing about what Flutterflow does is that I don't know how they do it exactly, but they have all the project configured, so it builds, which means that you don't need to manually start adding like Firebase services into your Xcode project, or you don't need to configure your push notifications or anything like that. So it works already in Flutterflow. So that's what they do really well. And for those of you who are a little bit more visual, I tried to do this in like Miro board. Okay, let's see. Yeah, it works. So you can imagine you have these three swim lanes, which are third-party services, the customer Git, and what Codemagic does. So whenever there's a build trigger that's happening, you send the API request with JSON parameters, and this starts a Codemagic build. And then what I've done with my application, but it's not necessary with Flutterflow, is that you can get your app configuration file from either your server or some other server. In this case, I was using the assets from S3. And then some customers, what they also do is if they get like, they can have one workflow that changes the Xcode project. So you can swap out the bundle IDs and any other things as well that might be within this project if you get it from your CMS. It may not be as easy as moving the hero PNG to the assets folder. It may require something more, but you can do all of that. Then what happens next is that you get the signing files from Apple Developer Portal. We use automatic code signing and start publishing it to wherever you want. So that's how it works. But there's one thing that is missing here. So, and Flutterflow is a bit unique in the sense that each of those projects that they had a unique GitHub project, basically, a GitHub URL. So you also need a way to create a project for each of the customers that wants to publish. Whereas most other customers, they have one GitHub project and then just use a workflow that switches out everything. So in this case, the team was really helpful, and we exposed them this API and gave them access to it that allows them to automatically create new projects in Codemagic. So that when a new customer tries to set up publishing to the App Store, then they can create the project on Codemagic, and then this will be a standalone project, which makes it more secure as well for the customer and helps debug it as well. Yeah. And I guess one thing that I didn't mention is that what I showed with this get build information is that whenever you start the build and you get the build ID, this helps the support team to debug it as well. So they can just open up or get the logs, for example, and then they can use their own tooling to make the reading logs easier or something like that. Okay, this was faster than I thought, but that's all I wanted to share. So thank you very much. Do you have any questions? Yeah.
Do you have are there any benefits to using like the config files over just like whatever's in the Codemagic GUI?
Yeah, so the GUI is a great way to get started, but there are some limitations. Like, for example, you don't have version control, which is the biggest one. So whenever someone makes a change, you can't revert back, which is a big one. And other than that, you can do everything in the GUI as well. So if you have a simple app that just needs to publish, for example, it's quite easy. But when you work in a team or when you work in some kind of agency that builds applications for other customers, one thing that I've seen that like Very Good Ventures does, for example, is that they have a template file that juniors can set up, and it helps them teach and understand what's going on rather than just configuring something from GUI. Yeah.
Thanks.
That's right.
Yeah. So we're currently using GitHub Actions with Fastlane. So what are the like main points that maybe we should change to your product? Like, are there any obvious advantages?
The way we think about it is that we try to classify some customers into like what is the real pain that they're having, like why are they switching to us?
Mm-hmm.
So one type of customer that's switching, for example, is if you have someone that set up Jenkins and left your company, then you don't know how to fix your pipeline, or when there's like an Xcode update that comes and you don't know how to set it up, then you may struggle like weeks on end, or you can switch to Codemagic. So another case is when you have this white label application idea, or when so you have a complicated use case and you don't know how to set it up yourself. GitHub's not going to tell you how to do it. So we can show you how to do that. But mostly, if you have something that's working, there's never really a need to switch. Like if you have your pull requests running the tests, if you have publishing working to the store, Fastlane works fine as well. It's usually when something starts breaking or like your bills go really high up. Like we've had some customers coming from Bitrise, for example, because they had like pricing changes. So then they're asking like, how much does it cost? But it really depends like what's the real pain here. Like if you can't afford it, it doesn't work for you anymore, or you can't scale it, then that's like when people come to us usually. Yeah.
And Codemagic, sorry, Codemagic still don't have any support for deploy for Firebase for a web project or something like that, right?
No, it does. You can, or for web project, I think we don't have a built-in support, but the beauty with like, what we actually do is we provide you a box. It's just a macOS box or like a Linux box. You can do whatever you want with it. And we've built some tools to make configuring it easier. So if you want to publish to Firebase web hosting, you can write the publishing script. We have the CLI on our machines, and then you just run it that way. Yeah. Okay, thank you so much.
We're going to take a short break. If you'd like to grab some refreshments, we'll see you shortly. Thank you.
This year she's starting. Well, in 3 years. It's cool, right? 3 years. Kew garden. Kew garden. And this is half on trees. High on trees. You're walking around and it's all shaking. It's crazy. Kew garden in Richmond. Look at this. Look at this. You go up there and you walk around this way. To me, that's the best thing. And you can do Richmond. That's in Richmond Park. I think you can buy it. You can buy it over there. Saturday or Saturday. 40. So everything starts back up at 11:40, yeah?
11:15. Oh, 11:40, yeah, sorry, but this workshop for this is some other stuff.
11:40.
Okay, so 11:40 is when you're back.
Yeah,
Yeah, sorry, part of the schedule changes.
okay. Yeah. So what's this online should be okay, right?
It should be fine. Yeah, and if anything, just reach out to one of us if you're already.
Sure, sure.
Thank you.
Yeah, a little louder.
Yeah.
This afternoon. Cool. So our next speaker is Shourya Kelkar, and he's gonna talk about Flutter in eyes of 20-year-old. And I. Wow. 12-year-old, and it's gonna be exciting to see it. Please welcome.
So, as my name I'm Shourya Kelkar. The title of this talk is going to be about Flutter from the eyes of a 12-year-old. But still, I don't look like one. So this is how it's going to work. The first few minutes will be about my background and introduction. Then I'll start about my coding journey towards Flutter. After that, what are my future plans in Flutter, and then we can leave questions and answers for 5 minutes at the end. So let's get started. Currently, I'm studying in year 8 in Croxley School. My hobbies are badminton and computer programming. And I love to play the guitar, and I also play chess. So I think I started my coding journey around the age of 2 or 3 when I started playing Lego. When you start playing Lego, you learn basic concepts like how to follow simple instructions to reach your goal, to make an aeroplane, a car, or much more. This is quite a resemblance to computer programming, in which you give some instructions to the computer and the computer follows them. The instructions are called algorithms, and in the Lego language, the instruction manual is the algorithm. Now, after Lego, I wanted a bit of challenge, so I went to Scratch. At the age of 7 or 8, I was introduced to Scratch. In Scratch, you learn the basic fundamentals of coding, like iterations, sequences, variables, and functions that are used in all the coding languages around the world. In Scratch, you also learn what is an animation, how to animate, how to make games, and much more. Now, let me just show you some of the games I have created in Scratch. This is the shoot the monster game, in which the player has to shoot the monster. I've used functions and variables to keep track of the monster and the player score. The player is also pivoting around the monster and using arrow keys. The next game is, you may already know, the classic Flappy Bird game. The Flappy Bird game is a replica. If you pass through a pipe, you get the points shown on the over here. Then you've got, if it dies, it will restart the game. When restarting a game, it has to press the button to restart, and it's also got the back animation of the moving ground. After that, now at the age of 9, I wanted a bit more, because I had got used to Scratch, so I wanted to go into the world of mobile app development. So I got into MIT App Inventor. It is like my fork, so I could go left or right, or choose right, and got into MIT App Inventor. It is like my turning point in my coding journey. So let me just show you some apps I've created in MIT App Inventor. One of them is a mini wiki app in which there are 2 countries, Peru and Bali. When you choose any of them, you get some information, a picture, and yeah. Then you there's also a search bar or functionality so that you can search different countries. And then you gotta catch the fruit game, in which there is catch the fruit, and you can use the 2 buttons to move left and right. Now, this is my favorite app in MIT App Inventor. It is called the French Vocab Helper, in which basically you've got it's basically targeted for people who are new to French. And what happens is, it is also on the Google Play Store, and basically if you press on any of the buttons in French, you also get them translated and spoken out to see what are the acts and how you should speak it. I also got a French translator. Now, this is a big billion-dollar question here. How did I get on Flutter? So how did I find about Flutter? So I've created many apps in MIT App Inventor. But the problem was that not all of my friends had Android phones. So not all of them could see it. So what I did, basically my mom introduced me to Flutter. Now let me just tell you about how App Inventor helps me to understand Flutter more easily. So as you can see, on the left hand side is the MIT App Inventor, and on the right hand side is the Flutter. I've created the same design but in different platforms. On the left hand side, the vertical arrangement is like the column in Flutter. The image is like the image of that Flutter. The label is like a text, and buttons in a table arrangement, which is like buttons in say Windows. And then the right hand side, you got the image like grid view, container, text, and ink well to make it like a button. Now another example of this is the random function. Now before I did Flutter, I did Python, and in Python I created a random number generator machine. And in that I found out that all the coding languages I have done up till now, basically I've learned that the random function is exactly the same, like the logic for it, but the platform and the code are different. So you can see one of them is Sketch, the fruit game, in which the fruit is coming from random areas of the screen, exposition of the screen, and they're coming at different intervals. Then the Dicey app, which you might already know, which is from the Angela Liu course, is that when you press the shuffle button, the different outcomes are shown on the dice, which are usually randomized and using pictures and expanded widgets to show this. Now, let me tell you my Flutter roadmap. So how did I start Flutter? Basically, first I was started with Angelou's course. Then after doing that, I did learning widgets and layouts. And using basic widgets and layouts to make beautiful UI, I made this identity card app, which has a name, columns, rows, containers, as you can see, padding. Then after learning widgets, now many of my apps are quite often connected to my day-to-day life. So basically, we had given a periodic table in science, and I wanted to make it a bit more reactive, like action bit. So I created it into an app, which is the periodic helper app, in which there are different categories and different pages and different elements. But the new concept I learned in this is how to create a model class, how to model the data and connect it to my app, how to use dynamic pages, because as you may know that the periodic table has more than 118 elements, and I did not want to be creating that many elements. It could slow down my app. So that's why I've done this. Then I have also after going with Firebase, I am learning how to integrate Firebase with the web platform. And doing this, I have now, after doing this, I can connect it with the Firebase database and now update my apps. And now to keep it in practice, I've just been doing all the apps I've done is now integrated with the web platform of Firebase. So now let me tell you one important concept in Flutter. Now, suppose you're lazy like me, and you do not want to write loads of code. So I use a package. Importing packages is like extra blocks. So you're making a Lego, but a Lego car. You wanted to make it fancy, to make it a bit more designed. So you put some extra blocks in and make it more fancier. This is the exact same thing with coding. You've got a program and you want it to have some extra functionalities. So you put the importing packages, and instead of writing 100 lines of code, you just import it and write one line of code for each functionality that it supports. Now let me tell you my things I would like to learn in my Flutter learning path. So I'd like to learn about state management. In the Flutter community, there's like so much noise about state management, like this is stateful, stateless, getX, block, and I would like to learn like which are the good ones, like what is good for some. If I want to make a fast project or slow project, or it depends on what I want to make the project on. Then API integration. How to integrate Google Maps. Suppose I would like to make a delivery app, and the delivery man wants to see where the user lives to deliver the whatever he's delivering. That's why I need to use Google Maps. Then responsive designing, so it's available on all platforms, web, desktop, and all mobile screens. Machine learning with Flutter, and animation, and many, many more. Now in school, let me just tell you my opinion on should students learn Flutter. Yes, because Flutter is very easy to understand. Flutter is very fast to learn, and Flutter community is very helpful. These are just the brownie points. Now, in school, they taught us that sharing is caring. So what I've done now is I'm sharing my knowledge with other people. And I've tied up some NGOs, and I'm mentoring some underprivileged children. What is a computer, how to code in Scratch. And in their gratitude, I also received a certificate of appreciation. You can see. Now, I just want to say thank you to GDG London for giving me this wonderful opportunity to share what is Flutter like from the eyes of a 20-year-old. Thank you. The first person to ask me a question gets a sunglass.
what did you find the most difficult so far in Flutter?
Just learning the Flutter widgets because it's hard to get my head around it. Because suppose I've been doing block-based code because there's two types, right? Block-based and text-based, and I wanted to, because I've done MIT App Inventor and Scratch. I did some bit of Python, so I know a bit text-based, but this was completely new to me, and it was quite hard to find out the buttons, the properties like the text, like the height property, the parameters, and all of those quite got my hand around. So it's quite difficult for me.
Well, good luck. Thanks.
Thank you. And
How did you find hard to teach or mentor others?
can you repeat?
How did you find hard to teach or mentor others?
Basically, it was not hard because basically I learned about that. So I just wanted to share my knowledge. In my holidays, I just got the time and there were underprivileged students, and I want to see the smiles on their happy faces. So I just gave up my time and mentored them.
Where do you see yourself in 5 years? Typical interview question.
A good developer, actually, yes. Good Flutter developer, like you people, like what you are.
Well, you're probably somewhere close to my level, so I need to learn more. But nice. Do you still see yourself in Flutter, or you already know what else you would like to
I would like
pick up?
to do Flutter, but with machine learning in it,
Nice.
like robots and something else. Any other questions? Yeah.
Just want to say well done. That was really inspiring. I can't believe you're 12. But also, obviously, you are the future of the industry. But do you also think Flutter is part of the future of the industry?
I do think because Flutter is for two. You can make iOS and Android, correct? So suppose you want to make a machine learning or you want to control a robot, you can easily do it by Flutter because if you see on the Firebase console, it's got this machine learning page, and in that it's got different like to identify different attractions or like that. So this is the future. Flutter is the future. Thank you.
Thank you.
Oh no.
No, I won't.
Yeah, probably do that one. Do that one. Probably.
Yeah. 2 hours. It's all right.
I'm not planning to read it today. Generally, don't need our help.
Yeah, we're worried.
Yeah, I think for the most part, there's obviously mistakes I've done.
I'd like to reckon. Hello. Sumith is ready to do his presentation finally. So, welcome to the stage, Sumith.
Are you ready?
Yeah.
All yours. Will you do the introduction?
Yeah, so I'm just gonna talk about the TikTok Pomodoro app on Windows with Flutter and Realm.
Thank you. So I didn't knew that it was a 12 o'clock session, like the things have been changing, so I have to come from upstairs, so still catching up my breath. So I'm Sumith. Today we're gonna look into Windows with Flutter and Realm, something that has been in the mix for some time. So after they announced it, I thought to tinker with it, and then was thinking, what should I do with it? Like, how can I actually show it to people, like, some work. So I built up a TikTok app, which is basically a Pomodoro app. Yeah, I use that a lot of times to make sure my life is in place. Yeah, so like, okay, I need to do some stuff. So I said, okay, that's something I use it. So why don't I use Flutter with it? And then exploring more and more, I started using it with Windows, a bit more deeper. I heard this thing called Realm. I'm like, okay, let me actually even use that to see whether we can actually use all the three to build an app. Yeah, so that's what this talk is about, to exploit those things that has been said out there around Windows, Realm, Flutter, to be a pure multi-platform app. About myself, I've been in this industry for some time. I've worked across mobile, web, even Windows, desktop, Windows Mobile, if anyone remembers that. So I had my journey through this thing. Yeah, so been working as an architect, CTO, had my own agency once upon a time, currently a product manager. So by skill, I'm techie, but by profession, I'm still product. Yeah, so those manager titles. Yeah, I am a GTG lead for London and in other parts of the world. Also, I'm an active community member. Just before I start, promote us. This event takes a lot of effort from organizers and ourselves to actually have something like you and have you guys here. So this is a moment of take selfies, put it out there, and I think we can give some giveaways also. Yeah, so there are some swags also. Yeah. So just lately they announced Flutter 2.10. I'm like, okay, what's going on? Yeah. So we know that Flutter 1.0 came 2018, and then 2019, 1.5, and so and so and so. So just a few months ago, they announced Flutter 2.10. And this is when they spoke about Flutterflow, Realm, Codemagic, and other partners they're partnering it as a supported platform for Flutter. Yeah. So two things catch in my eye. One was Windows, another one was Realm. Yeah. Like, okay, I understand REST, but these two could be a good combination to actually build up an app. Yeah, I want Windows app. So officially, what does that mean is Flutter for Windows is supported now by the Flutter team. So you can actually use Windows to build your apps. Yeah, so now you can build an app for iOS, Android, and Windows, same code base. And then I used Realm and MongoDB. So this comes from MongoDB. I used Realm for iOS before, and then I didn't for a while, yeah, because there were other platforms. So when they said there's a support for Realm for Flutter, that actually got me excited. Said, okay, let's try again. Yeah. So that was one of the things that was the reason why I picked up this talk. So Windows is stable now, so you can actually now add Windows support. So this is the architecture, and supports the same Material UI, widgets, renderings, uses the same C# C++ engine, which is Kia, and then it actually goes all the way down to the Windows embedded. Yeah, so you can actually use the Windows platform itself, like the GPU and the COM components from Windows. Yeah, for your app. Okay, and then all of these support for APIs within. Yeah, so serial port, gRPC, Win32 APIs, connectivity. I can even do battery. So you can actually create a small module to check your battery for a app. It's like, wow. Yeah, so that's also interesting. So there's a lot of good support there. The app which we will be looking at will not be using this, but I think it's a good thing to explore that you can actually use the Fluent UI and the Fluent Arctic UI to customize the look and feel of your app to look same as Windows. it's a bit pain in the ass because then you have to have like things in the app which says which device it is. Yeah, so if you are doing it for all the platform, then you have to put these things in. But if you are just saying, okay, I need to create a dashboard, yeah, for my Windows app, and then I create like an admin screen, and then something different for my mobile and web, you can actually be in the same code base, yeah, and build similar apps, yeah, and share the code. So that's what. So what I liked is basically there's an adoption from Microsoft. They also are excited about it. Yeah. So this code was good, like saying, okay, we're delighted that Flutter for Windows is now official. Yeah, and there will be some contributions from that team also within the open source platform. Yeah. So as a highlight, you can actually create a new project. You can so. The filthy bits are basically the difference between a mobile app and a Windows app is basically the keyboard, the way you take input from the user. So improvement on the text handling, yeah, because now you are using the keyboard. Then shortcuts. So Windows is very popular. You want to do all tab, so support for shortcuts. And then accessibility was one of the key features that was built in 2.10. So how do you get it? Yeah. So again, there is documentation, so docs flutter /desktop. So the first thing you need to do to have it enabled on your machine is basically flutter config enable desktop. Yeah. So just like flutter config enable platform basically, and then one of the option is desktop. Yeah, you can do Mac OS, blah 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 blah. But that's the first thing you need to do to have it enabled on your machine. Then the second thing is basically create. So if you already have an app and you say, I would just want to change it to see whether it supports Windows or not, you actually go into the app and say Flutter create, and the platform is my Windows. Yeah. So it actually then creates a new folder for Windows and have the support in there. Okay. There's one interesting fact which I wanted to bring it in. It was very like down there in the documentation that you need Visual Studio for developers. Yeah. So the Visual Studio is needed. And there's like which edition is like Visual Studio Community Edition, so that has to be installed on your machine, and that is Community 2022. So I had 2019, it didn't work. Yeah, so it's like it's there somewhere. It's like, oh, okay, I need Visual Studio there. Yeah, so that's something which is needed, and I think I know for sure the reason is basically COM support. Yeah, so you need COM support, which comes out of the box if you install Visual Studio. Okay, then the second thing we wanted to look at is Realm. Realm is a service which basically helps. So it is on top of Mongo. Yeah, so you're using NoSQL style database, but what it supports is offline and online support. Yeah, so you can work on your app. You can actually save data for a particular user on the app itself, and then the moment it comes online, it can actually push data to the web. Yeah, so it has all of those facilities. Yeah. Then if you use the Realm application services, it gives you functions, triggers, GraphQL access, which was added lately, and data access control. But for us, it wasn't all of that yet. Yeah. So it was just an introduction that Flutter now supports Realm, but not all of it. Yeah. So what does it do? You can actually add Realm support by just adding a package from the team. So pub add Realm, and then it only supports local Realm database. So you can actually save data offline. That's the first release. Yep. So you cannot use the Flutter SDK to connect to the application service, which I mentioned in the previous slide. Yeah, it's coming. That's what I heard. Yeah. Or you cannot use the Realm Sync. Realm Sync was amazing. Like if you have used Realm for your mobile devices for iOS, the moment you go online, if you have multiple devices, you can actually move data. Like the moment it comes online on iOS, it can actually sync data to Android, vice versa, or even web. So these are the support that we are looking for, and hopefully they come back very soon. Yep. So what I will be using is basically something which created as a code lab. Yeah. So for people to go offline and continue this journey with me. So this is a Pomodoro app. If needed, you can scan the barcode. You get this URL that you can use. We work together to build this app. This is the look and feel of the app. Yeah. I'm going to go to that page, which I thought I had it open. It describes what we'll be doing. Yeah, so we'll be actually using Flutter Realm in this code lab. These are the screens that we will be building. A simple Pomodoro app, which has a timer in the middle. Actually added another timer, yeah, just for fun. So there are 2 timers there. Yeah, one is a timer which is like a spinning reverse clock, and then one is a countdown timer. And then the use case here is basically every time I want like an egg timer maybe, and I'm like, okay, how can I use the same timer for egg timer? So we would like to have different types of timers. Yeah. So for that we will have a settings. Yeah, saying okay, I would like to create some timers, and then while I have that set, I just want to create that timer. And this use case is the reason why we would use Realm. Yeah, so because I would like to store that. Yeah, user is basically defining his own timings, and you can store it. You can take it to the next level where you can actually store it to maybe Firestore, or when Realm comes in with application services, you can actually store it in the cloud. So every time when you actually said, okay, I started this thing, I started work, I stopped work, I saved the work, so you can actually go through the history of the things you were doing on a daily basis, yeah, which makes you actually a bit more active. Yeah, so that's the thing that we'll be building. Yeah, so this is a structure of the app. Yeah, so we'll actually use some data and then models, providers, screens, services, and widgets. Yeah, so let's start with creating the app. Before I move to that, yeah, I just wanted to show you guys Flutter Doctor here. Yeah, so Flutter Doctor, when I ran that, yeah, it actually says I have VS Code installed. Yeah, that was one of the prerequisite. Sorry, Visual Studio installed. That was one of the prerequisites for you to actually have supported for Windows. Yeah, so that's something if you run Flutter Doctor on your machine, make sure. And if you want to run it on Windows, make sure this is installed. Yeah. Okay. I'll do a lot of copy paste. You can actually use the same code at home and make it work for you guys. Okay. So I mentioned in my previous slides, to support for Windows support, you need Flutter config enable Windows desktop, which I have already done this on my machine. Yeah, but if you want to run that, you run Flutter code enable Windows desktop, and then if you had a previous app that you have used before and you wanted to convert that to Windows support, you actually basically say Flutter create then platform Windows and then a dot, yeah, which means that you're actually on your current directory. In this case, that's this one, yeah. Okay, and then if you want to just run it from the command line, you run the app for device Windows, yeah. So Flutter run Windows, okay. That's the app. Okay. Oh, it opened up. Yep. So that's this. So what you'll see is like if you have it supported for Windows, you'll have a new folder here. That is the Windows folder. Yep. So just like you had for iOS and Android, for Android and iOS support, now what you'll be having is you have Windows support. Like I also have on my machine the web support, so I have the web folder also. Yeah. So the main code that we do is basically in Flutter is in the lib folder. Yeah, and if you also noticed, basically you then also get a support for Windows in the available devices on VS Code. Yeah, so over here, okay, people can see that. Okay. So what we'll do is basically we'll quickly update the main file. Yeah. I'll actually use my had the code in the source control somewhere here. Generally create like a class for all the constants. So should pick it up. Helpers, app constants, not found. Helpers, app constants is empty. So what I'm doing here is basically just some constants file for my theming. So the color of the app, the green color, I just want to put everything in one place. Yeah, so this is just a theming, nothing special here. And hopefully I will be able to import that now. Yeah. Okay. So we enable Windows, just 1 second. Yeah, we enable Windows and then we have a main file. So the idea here is to basically run this app on Windows platform. Yeah. Yes.
Could you zoom in a little bit?
Okay. Trying to see how can we do that.
It's the glare of the lights. Can we notch the lights on?
No, it's just the text is quite small.
Yeah, there's that as well.
Trying to do plus, but no, that's a minus. Yep.
Cool. Thank you.
Yes. Cool. Okay. So nothing special here. Just a title. Yeah, and then I have an app bar. Yep. So let's see if you can run that. So what it's doing is basically compiling code for Windows in the Windows folder, yeah, under build. Okay, so it's launching main.dot on Windows in the debug mode. So it takes time for building the app on Windows. Meanwhile, I think we'll prepare for the next thing. So what we are doing is basically we are creating certain widgets. You know, so if you look at the screen, we have a button, some circles, and so and so. So create a widget under widgets folder. So in here, new folder, widgets, and then we'll create a file called as action button.dot. Okay, so this is how the app looks like. Yeah. So right now we have the color which is blue, and it's running on Windows. Yeah. So we didn't have to do too many things. So it's the same material UI. We have the theming, yeah, which is from the app constants, just colors, and then we just ran it on Windows as a device. So that's the thing that we got after Flutter 2.10. Yeah. Although it was there before in beta, now it's obviously supported. Okay. So we just created a button which has a title and some click events. So these are just skeletons of widgets which I want for the app to do. So I'll just quickly run through some certain widgets, yeah, and then explain you guys. There we just wanted another one which is label. So a label text. Trying to build the app in 25 minutes. Yeah, lots of copy paste. So what this is doing is basically it is the label. So the counter label, yeah. So 0, 1, 0, 2, 0, 3. So the timer labels, and then the next one is I'm trying to create a countdown timer widget. Yeah. So that's the label countdown. Okay, I'm placing everything as a widget so we can compose the app, yeah, in different ways. Okay. So what we have is basically 3 widgets that we would like to place it on our app, which is main, yeah. So we create a new page under a screens folder, which is the home. So we go into lib, create a new folder, screens, new file, homepage.dart, and that would be our home page, yeah. Then go in, click this piece of code, and then go to the main.dart and change the app. Instead of going to home page, instead of going to main page, go to home page here. Import that. And get rid of the rest. So what we did there is basically we have the boxes where it says 00, 00 minutes, 00 hours, and 0 seconds. Those were the labels, yeah, and these were the buttons, yeah. So just want to dissect what we just did, yeah, within the last few seconds. So on the main.dart, we're saying, okay, go to a home page, and the home page definition is basically where I'm saying I want a countdown timer, yeah, and the countdown timer needs to do some animation. It has to go down, yeah. So for that, what I actually have is basically I need to zoom to my zoomed in, yeah. So for that, what I have is an action button saying, okay, when you click on the button, yeah, start something on the countdown timer, yeah, and then you can pause, resume, and stop, yeah. And then that is all handled within the label countdown timer itself, yeah. So it says, okay, restart what you want to do, yeah. So this is where this piece of code lies, yeah. So from here to here is our label countdown timer. This piece is this action button from here to here, start, pause, resume, and restart, yeah. And the label text are these big text. So these are the 3 widgets that we worked through. Okay, so if I hit start, it starts the counting. If I pause, it pauses it, and resume and restart. Yeah. So that's the functionality that we just did. Yeah. Nothing special here. Yeah. So what we made is basically a countdown timer that runs on Windows. Yeah. So that you can have it on the side of your desktop while you're doing something. Yeah. Where you can start, stop, and pause. So the next functionality, I think just for fun, what I also did is basically I did like a circular timer. Yeah, so which goes like backwards so that you can actually use it to see how much time is left. So for that, I'm using the circular countdown timer widget. So quickly add that using PubSpec assist into my PubSpec, and also I'm adding another dialog. Yeah, when the timer is complete, you actually get a notification. Okay. We create a new class for the countdown timer under widgets again. So go to countdown timer.dart, new file, countdown timer.dart, and then again quickly copy paste. Then what we are doing is basically hooking the countdown timer to the home page. Yeah. So if you look here, basically this is where I'm hooking it. Yeah. So on top of the label timer, I would like the countdown timer. Yeah. So countdown timer, how much time does it need? Duration in seconds. What happens when the timer is completed? So initiate a time completed event, etc., etc. Yeah. So again, a big copy paste. So what we have now is a timer up there and a timer down here. Yeah, so one is a label, another one is just that. You can actually build this app and have a settings which one to show. Yeah, like okay, I would like to show a circular one, or I would like to show a label one. Yeah, so that could be another thing that you can do with this app. Okay, and then actually it should react to the same buttons. Yeah, so if you look at it, when I'm hitting start, it starts at 10 minutes. Pause, resume, start. So both the timers are acting at the same time, yeah, for the same actions. Okay, so till now we actually have 2 timers on the page. What we don't have is basically the thing which I said. Yeah, I need a timer type. Yeah, like I'm right now hard coded it to 10. Yeah, but I would like to change that. Yeah, so that's the main reason why we wanted to use Realm. Yeah, so it's like an idea to come up with using Realm. So we create a new class model.dart under the models folder. Yep. So new folder, models, new file. Yep. Too much model.dart. And then I created like a model, and it's an ID, type label, in minutes, and whether you want to go forward or reverse. Yeah, it could be like you want to start from 0 to 10, or you want to come down from 10 to 0. Yep. Okay. Then what we'll do is basically we'll create some dummy data for now so that we can see it working. So we actually, under the data folder, new folder, data, create some dummy data, data.dart, and just have that dummied out. Yeah. So what it's doing is basically saying there is a label, work label. There's 25 minutes, 10 minutes, 5 minutes, 3 minute, and 1 minute interval of these timers. Yeah. So just some dummy data for us to see it on the screen. Okay, going down. Now what we'll do is basically we'll create like a custom button bar where the user can select that. It's like a tab, yeah, on top of the screen. Yeah. So I'll create a tab under widgets called as custom button bar. And I will see how it looks like soon. So what it takes is basically the Pomodoro data type, the list of buttons that we defined before. Yeah, so 4 of them. And then it just, when you tap on it, it will change the state of the timers. Yeah, so it will change saying, okay, what is the duration of my timer? Yeah, so it could be 25, could be 15, whatever. So save all of that. And the UI, nothing changes yet. Yeah, so what we need is basically on the home page, we would like to add that custom button bar. Yeah, so it's done on the top. So if you now go back to the home page, so this is how our current home page looks like. Yeah, nothing on top. Yeah, and it's plain. So after I save this one with some errors,
You got a typo.
You got a type on
custom button.dart. Edit it. File name. Custom button bar.dart.
This one?
Yeah. Edit it.
Thank you. Always save nature. Okay, going back to homepage. So at least one was paying attention. Yeah. So I hit save, and did I hit save? Yeah. I didn't see the effect of it. have the custom button bar here.
Your report.
Yeah. So that's what we were expecting. So on top, you can see now button bar. Yeah, work, long break, short break, 3 minutes, 1 minute, and you can keep on adding it. Yeah, so you can say, okay, as a user, I would like to create my own custom timer. Yeah, I don't want to be stuck with. So it's like you can create an egg timer out of it. Yeah, can iconize it and so on. So that's creative. Yeah, that's where you can take this app further. And then when you click on that, it actually changes the time. Yeah, so it's like the short break was 5 minutes. You remember that was kind of hard coded in data.doc here. So that's here. Okay. Okay, so we got that going on. So the last bit of my talk is to use Realm. Yeah. So we have everything hard coded. We have like an UI where you can actually run on Windows. Yeah, and have something running on your desktop as a timer for you to play around. Yeah, but the next thing is basically I would like to save data. There are multiple ways of doing that. Yeah. You can use local storage, you can but that's like, okay, let's just play with Realm. Yeah, it's more fun. So we'll create like a setting screens, and a setting screen is where the user can actually set the timers that he chooses. Yeah. So for that, well, let's create a new screen so that we can actually have a place where we can actually set this under screens, new file, setting screens.dart. Take the entire code from here. How much time do we have?
We are a little over.
And then what we'll do is basically update the home page, yeah, so that we can navigate to the settings screen. Yeah, so we'll look for something like go to setting. So that's my home page. And somewhere here, this I'll actually say go to home page. That actually asks, do you want to import settings? Yes, that looks all good. The last bit is to basically plug our icon to go to setting here. So let's look for that. And this is the setting place, and over here. Sorry, I scrolled too much. I'm pressed, go to setting. Okay, so this will take us to a setting screens, yeah, but we haven't plugged Realm yet. Yeah, we just created a screen. So if I then save that, you can see if I click on this button, it will take me to a place ready-made for you guys, yeah, which has a text, some kind of a plus and minus, but the save is not hooked yet. Yeah, it doesn't do anything. Yeah, just you can say work to, but it doesn't do anything yet. So the last bit for that is basically adding support to Realm. Realm is new, so if you go to pub.dev, yeah, it still says it's in alpha. Yeah. So it has moved a little bit, yeah, but it's not. It's like, be careful. We want you guys to use it, but don't use it for a big app yet. Yeah, but it's a way forward. So it's another alternative to storage. Okay, so what we will do is basically just like that. We will actually install Realm. So Control-Shift-P, spec, Realm, and then that. And then we'll update the model to actually now store something in the database. Yeah, so we'll modify the model, which we already had. And I was actually being a bit more futuristic that I would like to save the run history and everything else of the user. So what Realm, the way Realm works is by attributes. So over here, there's an annotation called as Realm model. Yeah? So I switched from being a normal class model to be a Realm model. Yeah, and what it does is basically creates that particular table within the Realm storage. Okay, so it says, I don't know, Realm, can you actually do that? Oh, we got it. So one thing it needs when you create a Realm model is basically you need a part file, which is model.g.dart. Yeah, because it will auto-generate the code for you that is needed to plug in with Realm. And to generate that file, I will have to stop the app first, go to my terminal, and run flutter pub run Realm generate. Yeah, so we don't have the model.g.dart yet over here, but this has been annotated with a realm model. So it identifies that this is something which you need to store in the local database. So for that, you need to generate the file. Yeah, so Flutter realm generate. And then it supports all the fun stuff around around primary keys. So you can actually set something as a primary key, integer Boolean. Interesting one, which is something which I found is not supported, is date time. Yeah, so actually have to convert the minutes to integer, because right now local database does not support date time. Yeah, so this is mistakes here. Okay, so hopefully that has been generated. Nope. Oh, that's generated, I think. Yeah, so that took some time. It has been generated. Yeah, which means my my data has broken, and I right now don't care about you because I'll take you from the database here. Anything else broken? This says the data doesn't exist, and the settings says the data doesn't exist. Yeah, we'll bring it back. So we did that. Now what we'll do is basically we create like a database service within the services folder. So if we go back and new folder, services, right click, new file, database service.dart. Yeah. Okay, I think that's the last bit of it. I'll take maybe a minute. We save it here. So what this is doing, and I think this is the last bit, then you can follow the rest of the thing on the code lab. Yeah, is saying, okay, I need to go into realm, and I need to have a configuration, yeah, which is the configuration service that realm provides. Yeah, and then in the constructor, I will pass the configuration itself. It will then go through the Pomodoro and add it to the database. Yeah, so realm.addAll will add stuff to the database. Then it's a basic CRUD. Yeah, so get all Pomodoro, delete all Pomodoro. So I'll just create a lot of these gets, deletes, and all the CRUD activities that I want to do within the app. Yeah, so that's the functionality within the app I wanted to do. And all of that, I just created a new database service file. Yeah, so you can actually swap it with Firebase or whatever you want to. Yeah. So let's go back to the code, and I think that should be the, that's a lot of code there. Yeah. So we want to store that into user data. So we'll create a file in models called as user data, new file, user data. So this is not exactly the one that we want to store in realm. We just want to have a static class or a mod or an object that we would like to pass across within that. Yeah, so that's the user data, and actually that I'll actually add an app user, which has the selected Pomodoro that I will use to change the UI of that. But time is up. Yes. Yes. So I know I think I still have another 5 minutes, which you can use. Yeah. So if you go through this this code lab which I have designed, yeah, for this one, you can actually get the entire app running on your machine, yeah, which almost looks like this, yeah, where you have the tabs which we discussed on top. You have the start, stop, and play for Pomodoro, and then you have settings that you can actually save on the local machine. Yeah, so you can say add timer, blah blah, and everything is using Realm. The same app can run on your mobile. The same app can run on Windows or web. Yeah, so there are 3 places, and I think the idea came through like, you know, I wanted to use like a start, stop, which I should be using right now because I've went over time. Yeah, but this was the reason why I was thinking, and I need to build an app, and actually took me 2 weeks to actually come up with this skeleton, which actually stored some code here and there, and had this for this presentation today. Thanks for your time. Hopefully you try this out at home, and hopefully you like the whole new idea of creating apps for Windows and using them for your apps. Thank you.
Sorry, can I ask a question?
Yes, sure.
Since you're the first one.
Oh, sorry. Like, what scenarios would you want to use Realm over something like Firebase?
Well, I think when they have all the application services ready, and you already have, I have actually worked on a Realm app before, when Firebase was not even a thing, and it is coming from Mongo. Yeah, it has the back of Mongo rather than Firebase or Google, so they know their products. Yeah, and then they can do. They have all those things like same things like trigger functions. It's just that if you're already having an app which actually uses Realm, which is an iOS app, and you're thinking of Flutter or Windows, definitely go for it. Yep.
Yeah. So there's not really any advantages using Realm.
It's almost at the same exactly same capabilities. Exactly. It's just learning curve. Firebase. If you want to not use Firebase, you just want to use Realm, which you already are using Mongo. Yeah, so definitely can bring those, because I feel like people who use Mongo, they know Mongo better.
Okay.
In terms of capabilities.
Thank you.
Okay. Any other questions? A few more things to do. Thank you.
He said, okay, let's build in Firebase.
You know, starting the camera. Hello everyone. So our next speaker is Pereira, and he's going to talk to us about micro frontend and CI/CD pipelines and design automation. So it's all yours.
Thank you. Hello, everyone. My name is Teresa. I'm a software engineer working for JP Morgan. But just have to say this in front, right? My talk today, the content is about my personal experience and my own project. Doesn't connect to what we do in JP Morgan. Nice to meet everyone. So I know I'm also a Google developer expert for Flutter and for Dart. So my talk today is about micro frontend. I'll talk about why we need it, how do we architect, how do we design it, and then I will focus more on how do we actually build the pipeline so we can release micro frontend project. Because you can actually build it, right? We can actually work in smaller pieces, but at the end, if we can ship our product in micro frontend style, we're not truly doing micro frontend, right? That's where I'm going to focus a bit more today on the pipeline. So let's begin. And I'm sure the majority audience here are from front-end background-ish, right? So I will go quickly explaining why and how, right, on the theory. But I will talk about why what is micro front-end. So micro front-end is about divide your project in smaller pieces, and ideally each piece would be owned by a team. And each piece will provide a clear focus. I will explain what clear focus means in my later slides. And each piece is independent. That means you can actually ship them independently. And of course, right, you have some center piece that is shared. And why do we need micro frontend, right? If you are working in a product which you have like a medium large size project, it enables you to have a cross-functional team. So the teams can have end-to-end responsibility for a feature. And it enables you to have autonomous team. So they have their decisions, they own their tech stack in their module. And of course, right, it's more effective. Sorry, I need to. Share it again. I'm not sharing. Oh, I lost my connection. Sorry, technical issues. Okay, sorry for that. Let's continue on why do we need micro frontend. And if you lost a bit of the slides previously, these are the content of where we are right now for audience who is watching online. So cross-functional team, autonomous team, and it's more effective, right? That means you actually have a smaller code base to work from. So every time when you do improvements, do refactoring, it's more effective. And of course, that's more efficiency as well. That means when you make updates and when you want to do some optimize, right? You have, again, smaller code base to work from. Okay, now we know why and how, right? We can work with micro frontend. In the next few slides, I'm going to talk about how do we architect, how do we build a project in the micro frontend style. In the beginning, right? In the first, I'll say the first thing you do is think about architect. You might start a project from scratch if you're lucky, but you might have to work from some legacy code. It might follow this domain-driven design, or it might not, but you don't have to stick 100% with domain-driven design. The idea of that is, if you start a project from scratch, you might want to actually have this concept in mind. That means every team, right? We think about domain or feature, right? Every domain has its own bounded context, right? With some specific rules and process, and with some shared value objects, right? Together in the middle. And you might want to design this with your backend team. So there isn't such a thing that your backend team is following some certain of domain design, and then you do again in your front-end project. It's not that case, right? When you architect your project, most likely your front-end project is going to be a mirror of your backend service. It's going to be your mirror of your backend microservice. It would be much simpler because you don't need to show everything what is happening in the backend. You will be the one that is interface, right? Be the one that showing to the user, receive the user interact. So it would be much simpler, but it would be mirror of your microservice. And again, right? This is probably everyone is probably familiar with this kind of diagram. Let's say we are building a fintech application, right? Or maybe you're doing a sports application or a video stream application. But I'm sure you have this team, right? In your organization. You have this team maybe onboarding, look after customer sign up, create account, payment team for money transfer, and the KYC for identification compliance. And you might have a service team looking after customer relation. And each team might have a cloud engineer or might not. But for sure you have front-end engineers, back-end engineers, and you have product people, design, and the QA. Maybe they look after more than one team. In the bottom, you have the core engineering team, or you might call it the dev experience, the platform team. So this is a bit generic view of a team, right? Which is cross-functional team. And this is actually how we're going to architect our project as well. So your team and your project will be roughly in the same structure. Once you have this domain set, right? If you're following the domain-driven design or feature-driven design, now we're kind of entering the process of actually building the project. I would say modularize is actually quite important. So that means you have a project, right? And you don't want a monolith of a project. You want to build the things in smaller pieces. So that's why you're entering this concept of let's modularize it. I have worked on a project before where every resource is put under one module, and IATing is in another module, and the features is in a different module. That means when I wanted to change a text on my app, I need to submit 3 pull requests for 3 teams. Is this efficient? Maybe not. So think about how you want to modularize your project. You will have this puzzle right in the center, which every other team would use or every other module would base on. The centerpiece might be your design system, your IAT, authentication, feature flag, the things that you're going to repeat, right? You want to share with every other module. And I will talk about maybe you might not need it. But let's say that you have this centerpiece, you share with everyone. On top, you have your feature module or vertical module, however you call it. It's onboarding, account, payment, right? Then you have the top, the main, that's where you enter your application. One of the tricky parts in this diagram is the navigation, the route. So navigation is actually quite interesting because it opens a gate from your module to another module to allow 2 modules to connect, right? So where do you put navigation? Where do you put this route? You can actually put on top, right? Somewhere next to your main app, your main the enter point. And that's where you assemble and start routing to your system. Or you can put the navigation as part of your core. So you own this centerpiece, right? You centralize the navigation in the core. Or you can break it down and each of the module to own its own navigation. But you might have a very thin navigation in the center for, let's say, similar like a proxy kind of navigation module, but very thin. However you decide to go with it, right? That's up to your team, right? So it's a conversation between your team. Again, right, depends on the project size and the project content as well. So these things varies. Choose whatever works for you the best. So once you have your modularization, right, and you start working on your project, we're talking about building a micro frontend project, right? After, let's say, a few months, right, maybe one engineer will say, let's try and draw our dependency tree and see how it looks like. And so you write some script, you run it, and you have this visualized dependency tree in front of you. It's like a mess. It's not that bad, right? You do have dependencies from one library to another library, but the key thing here, so don't be scared of this diagram, right? It's not that horrible if you actually look into it. But the key thing here is all the arrows should pointing down, right? You shouldn't have any arrow pointing up. That means you have circle dependency. That's what we want to avoid. So avoid circle dependency, right? You can use some package management libraries, like you can use Gradle, you can use Maven, you can use Linux, you can use NX Learner, right? Those libraries that you can use to help you manage your package. And then I would say code duplication is actually cool. I know we know this. If we went to any computer program course or university, right? The first lesson we can learn is do not repeat yourself. It's true. But in some cases, in micro frontend world, sometimes, right, duplication of your code is actually cool. It's actually fine. You can repeat to improve efficiency. And the key thing here is that we want to share knowledge, but we don't want to share too much code. Each of your module in the micro frontend project should be more or less self-contained, should have to be like one piece on its own. So when you want to update, you don't need to talk to 10 teams about, I want to make a change for the core module. Instead, you own those pieces yourself. The other team to have another version of the util library, for example, and that's actually fine. And it will actually increase the bundle size dramatically as well if you have this package management system in place. So before we move on to the last bit of how we're going to release our micro frontend modules, right? The last thing we need to think about is how we're versioning it. So we want to ship our project in smaller pieces, right? We will version our application. If it's a mobile app, we'll version the final app with version number. So the versioning here means actually how do we version each module we will release for other team to use as a library. So in here, right, apart from the versioning, the numbering, the tagging, those are three things that might change how do we version our project. The repository, do you use monorepo or do you want to use multi-repo? They're both fine, but the current trend is through using monorepo. And the Git methodology, do we use trunk base or do we use Git flow? Trunk base is having a one main branch, and every time you create a feature, you merge back to your main branch. That means every time you merge back to the main branch, your code is releasable, is deployed, ready. So you can actually bump a version at the time when you merge your code back to the main branch. If you use Git flow, every time you merge your feature branch back to debug branch, your code at the time is kind of unstable-ish. It's not releasable. It's not production ready. So you don't have to bump the version when you merge back. You can bump the version by a timing base, like once a day, twice a day, for example. So however your Git methodology is at this point might change the strategy of how you want to version your module. And think about how you want to assemble and how do you want your container app to choose which version to use, right? It could be managed strategy. So you choose, I want to use a version A or want to use a version B, right? Or version 1 or version 2, or it will be evergreen. So you always go with the latest released module version. Okay, so now after we decide our versioning, our dependency, our module, right? We start build the project. So everything we're starting to contribute to part of the project. Either you're in a feature team or you're in the core team, and our project, right, is actually growing. So we actually have some decent amount of code in our project now. And the next thing to think about is how we're going to release our micro frontend project. Regardless what kind of strategy we went right in the beginning, we know we can always release this project as a monolith in the end. If it's a web app or if it's a mobile app, right? We can always bundle it and then release it as one app in a go. But our end goal in here is to allow us to release the module on its own. So how can we do it, right? So a few things that to think about right here. The strategy for release is we want each module, right, to be deployable independently. We want to release on demand without restrictions or having dependencies, right? So each team, right? If I'm working in a payment team, I build a cool feature in my payment team. I want to release it. I don't want to wait for accounting or onboarding team to finish their feature so we can deliver all together, maybe every 2 weeks, right? I want to release my feature module at the time when I finish coding or finish testing of my module. So I want to release on demand without restriction or dependencies. So, and then having everything loose coupled. So avoiding having breaking change or introduce breaking change that would impact everyone else in a team. Then we need to think about how do we separate our pipeline. We might have different type of pipeline for integration, for release, and for deployment. So if we are releasing a project as monolith, right, in our sprint, we might release once at the end of a sprint, comparing to if we are running a micro frontend project, we actually will decouple release from development. And in monolith project, we will have this long-lived release branch that we create, right, when we're about to release, and it might have some bug fix onto it, or eventually we might have to cancel it, right? In the micro frontend project, this release branch might not be needed because we're going to release on demand. And you probably have this thing called the release train that sometimes you hit it, sometimes you actually miss it, or it's actually irregular. And in micro frontend project, we actually don't need release train anymore because we are going to release on demand. So the process would look like this, right? A team build the functions for a feature. Then this team, right, let's say payment team, this team will decide when to release this feature as on its own, right, in a small bundle. And they can use this micro release pipeline to build one module, to version it, and deploy this module on its own. It's possible. And then this new module is available for other team to use as a library or as a bundle, right? It might be more difficult for app, right? But we'll talk about how. That's the process of your release for micro frontend projects. Okay, now pipeline. We talked about having separate pipeline for integration, for delivery, and for deployment. You might not need all three of those pipelines. Again, this goes back to the Git methodology you are using. If you are using trunk-based or you are using Git flow. Let's say if you are using Git flow, you might need this pipeline called integration. That means you want to merge back your feature into the debug branch as often as possible. And this pipeline should be quick, right? It just runs some tests, maybe unit tests, integration tests. It doesn't have to go to the end-to-end test level. And this one should be running quite quick, maybe around 10-15 minutes to allow integration to the debug branch. And if you're using trunk-based development, your integration and the delivery pipeline might be similar-ish, because every time you merge back to the main branch, you are making a release, right? Release and the deployment are separate concepts. You can release as often as you can. You don't have to deploy it. So this delivery branch might be the full pipeline you want to run. So starting from unit test, integration, all the way to the end-to-end tests. So this one might run slightly longer than the integration pipeline. So you can separate them to improve the efficiency. The last one, deployment. Again, this one is optional. If you are building a web app, you might not need deployment pipeline because your delivery might be the deployment pipeline. But if you're building a mobile application, this pipeline, what it does is basically this one is protected, right? You don't want everyone to access it. That means every time you trigger this pipeline, you will bundle your application and then upload this app to Play Store. So this pipeline will have the credentials for you to upload to the Play Store. So you automate the whole process. So those are the three pipelines you will need in your project. And what does those three pipeline means for micro-front project, right? So integration pipeline remains the same as with or without having a project in the micro front-end style. But the release pipeline will change from releasing the whole application to release just a module. And the deployment, again, it's the same, right? It will act as a final assembler. And when we talk about, we mentioned about testing in our pipeline, right? So this is what you do in your project. But how you do your testing has a huge impact on how you design your pipeline and what can you test in your pipeline. If your test is kind of mixed, right? So you want to run tests in isolation. You don't want to run tests in the entire code base. So if I change a feature in a module, I want to just test things locally, isolation in that module. I don't want to run tests in my entire code base. So your testing strategy is actually quite important. It has a huge impact on how you can release your project in smaller pieces. And you want to reserve end-to-end tests for release instead of mix your integration and your end-to-end tests together. And the test in production is fine. I know it sounds horrible, but it's actually fine. You can do some A/B tests. You can do some kind of release to help your user, right, to use your app in production. Because every user is a tester of your app in production. And try to adapt some API tests to detect breaking changes, right? And you want to actually use end-to-end tests for just happy paths. Don't use end-to-end tests for both happy and unhappy paths. And in your team, right? In the end, everyone is quality assurance, right? Everyone cares about the quality. Everyone is a tester. You probably don't want to have a separate QA team, right? Every engineer should be responsible for the code they produce. And before I move on to my next slides, which is like the last one, I want to talk a bit about the Flutter naming conventions, right? I'm sure if everyone coming from the Flutter side, you might familiar with those names. For people who are new to Flutter, you might heard about app, right? That's the intro level. And we have this package called the lib. That's a library, that's a module every Flutter project will contain automatically. And then you have this thing called the package. So package is actually another library. It's a mini version of the library inside your Flutter project. You can create as many package as you want in your project. And then you have this name called the plugin. What is plugin? Plugin is actually another package. It's a special package which has native code in your Flutter project. So now we can use package, right, in the next slides. Let's comparing some of the frameworks, right, in the micro front-end world. So with iOS, Android, Flutter, React Native, and the web. For five of them, you can actually build by package or by module. So you can actually build the things in a micro frontend style. And you can bundle them by package as well. At the same time, you can also deploy them by package. So you can deploy a small module in your Flutter project and let other people to use it as a library. It's possible. And it's actually quite easy, right, in the web application to receive updates by package. Unfortunately, it's not that convenient for a mobile application to get updates OTA, right, by package, because we have to submit our application as monolith to the Play Store in the end. That's one huge difference between web app and native mobile app. So in the end, how do we succeed our micro frontend project, right? So remember, this is a process, right? It's not one-off task that you do only once a week, right? Or you do it like 3 months, that's it. It's a process. You have to continue contribute to the good behaviors of micro frontend project, and requires team collaboration. You want to design your project in a module way. Make sure there's zero circle dependency. You can have a dependency, but make sure there's zero circle dependency. You can start from the core module, right? Just suggestion, you don't have to. You can start from the core module and then slowly move on to those vertical feature modules when you release them. And you want to decouple your tests. You want to have your separate unit test, integration, and end-to-end tests. And in the end, right, you need to build a pipeline to ship this micro frontend project in smaller bundles. So that's my talk for today. Thanks. Time for questions?
We do. We have some slides that you can give away.
Thank you. Do you have any questions? Yes? I'll go lady first.
Actually, you go first.
I just wondered, Teresa, what your thoughts are on testing across versions when you do end-to-end tests.
Tests?
Because if you're doing trunk-based development, you're going to have potentially different versions in trunk and what you've got in your production release. And so are you using end-to-end tests to catch any version conflicts across those releases?
It depends on what you want to use the end-to-end test for. The one that we are talking about in my slides are more for before you release something. So it's focused on the current the code in your current release branch. But when you're doing trunk, right? Again, there are different type of trunk development. So you might doing the real trunk development, which is super awesome. But most of the time, people are doing scaled trunk based. So that means you do have a short-lived feature branch. You do code review as well. You're not doing pair programming. Then again, you might have this release branch created. So in that case, your end-to-end test runs on the release branch. So you might not have this situation where you have the version conflicts. But we can talk about this a bit detail after this talk, because I might need to understand a bit more of your context to help you to answer your question.
Sure, thanks.
Help me understand when you say testing production is fine, because there'll be scenarios where you'll take a health example. If your app is health related app, why there are consequences of testing in production that you really need to be mindful of. So I just want to understand the context that you say that in.
Yeah. So testing in production. So this means no matter how much tests we do in our project before we release, right? We can do 100% of unit test coverage, 100% of service tests, right? API tests. We can cover all that, but those might not cover the scenarios as from our user's point of view, from a real user's point of view. They might run into situations where we don't actually see in our tests, because those tests are designed by human beings, right? We might miss some edge cases. Test in production doesn't mean we don't test our code before we push it out. It means our user, our end user, are actually our tester as well. They will use the app daily more frequently than not us, right? Even though we dog food our own product, but we might not use as much as our user, or find a way to go through all the journeys they might go through. So those users, our end user, are our tester in production. That's what testing in production refers to.
Oh, I see. So, and any errors that are caught out of that, you will feed that back into improving and incorporating them in part of your integration tests. So you'd have a cycle to make sure that you're increasing your test coverage earlier on, so that you don't fall into those post-production.
Yes. So this is why in some team they actually started to adapt or use can never release. That means it's not increasing your users by percentage, right? It's a way to actually release the app, right? Only release the feature earlier to a small group of view user, like that actually your user, not people internally.
So that's
they will be the real user that you know who they are. Yeah. But and you can track the usage, you can track the bugs, you can catch them earlier. But again, right, it will be still some cases where you don't catch things in live. So that's how you need to build your monitoring system, right? Your analyze system, and you get feedback from maybe a crash, maybe just production issue, like a 400 issue, 500 issue. You catch them, and then that's where you can use to improve your product.
Yeah. So another branching strategy that works when you find issues in production is GitLab flow. That's actually a really good one. So you can feedback. So it's kind of an extension of Git flow, but uses issue tracking as part of so you can push out fixes a lot quicker and making sure that your development branches can absorb those fixes as well. So that's something to explore as well.
Yeah, that's interesting. Well, I will have a chat with you later about it. Thanks. Yeah.
You talked about the navigation and the fonting, micro fonting. It means that most of the time the micro features will be completely independent of each other. Okay.
Yeah.
Yeah, but sometimes you have to navigate from one feature for other feature.
Yeah.
Yeah. And how do you work with this? You have to know the path of the other features, because in this kind of navigation you are create some operation in this situation, but it's not a strong operation. It's just a string, then you know the path. But if someone change the path in the forward, it's broken. But how do you have something to check this? How this works for you?
Okay. Again, it depends on how you architect your routing system, right? Mm-hmm. So you can put everything in a center part of your shared module. So that means that navigation module will know literally every of your feature module. It actually sits on top of your vertical modules, right? So if you create a new screen, or if you change the screen name, you change the core navigation system. That means every other team will have impact with. That make your app a bit harder to test and to release as well. Another way you can go with is having each module on its own navigation. So everything internally, right? The routes internally is owned by that module on its own. But as you mentioned, right, there will be cases where you want to navigate from module A to module B. So this part, right, that means your module A will have a dependency on your module B, but you don't want to have this dependency in your module, right? Because that's circle dependency. That means you can actually have a very thin core navigation module to own this, let's say proxy, right? It's like open the gate to other module to know me. You can have a centerpiece of this navigation in your core module, but let all other navigation sit with its own module. So you might have two navigation systems. One is the shared one, and the one is the local one. It doesn't solve the problem completely, especially for mobile application, because you kind of have to hard code this navigation in a way. For web, it's definitely much more easier. Unfortunately, with those centerpiece, right, when you have to navigate from A to B, when you make a change, you have to test both modules. Okay. Yeah. I hope you answered your question.
Can you just confirm
it's bad to have dependencies from one micro front end to another. And if there were, if the two sort of like micro front ends were somewhat related, should they then exist in the core package?
Yes and no. So the core package, the definition, in my opinion, right, the core package is something that used by all modules, like design system, authentication, IoT, right? That is the core that I'm using. I'm going to use it for all modules. In one case, like navigation, you can avoid having these shared components. You can leave them in the core, or you can create something, again, depends, right? Some in some project you have that have this core module and that have a share module. A share module means I'm sharing this module between two modules or three. It doesn't solve the issue with dependency. It solves the issue with circle dependency because we don't want to have a feature module depending on a different feature module. Instead, we kind of abstract this layer out in a separate module. But apart from navigation on its own, because you have to hard code the screen by its name, there are cases where you probably don't want to have this share module. So you have this duplication of your code. Like you have to import library twice.
I would like to ask your opinion. So as someone working in a technology consulting company, I've never heard anyone of using Flutter yet. So do you think Flutter has a chance to be adopted by those corporation companies, so professional services, consulting, technology companies? What do you think?
Definitely, because if you go to the website of Flutter, you will see like it's being used by a lot of big companies, right? And the startups as well. It's not about saving your time to build the project, right? Because I mean the framework itself is very efficient. It's for me it's about how do we write the project and how can we make it more efficient to deliver the project. And Flutter is actually written in a way it's super efficient in both.
Mm-hmm. So for huge, let's say if you have large application and pretty big team, that might be the way to approach it. So then they can collaborate efficiently.
Yes, and also to build a project, right? It takes time, but doesn't take that kind of much time because you can create a feature very easily with any of the framework, Android, Flutter, or Angular. Mm-hmm. It's about how you ship it. That's where you will see the difference, a big difference between using native project comparing to cross-platform project, because you only ship once with one framework instead of shipping 3 times.
Yeah, I can support that question. So a lot of organizations are still stuck in they have a native iOS team, a native Android team, and so forth, and that's a cost, right? So they all want to shift towards a single code base. So Flutter is an option.
Well, coming from a consultancy, not seeing anybody going in that direction.
Maybe you can lead the way.
That's the idea. That's why I'm here today.
Similar.
Because they just in the end, the decision makers are stuck in their way. So sometimes a lot of the time they're not following new trends. So
the clients define the technology.
The question is not just about the thing; it's about how the ship. Because sometimes you have two different implementations of the same feature in the both architecture, the both platform, and have different bugs. It's crazy because sometimes when you receive some bugs, have to know it comes from iOS or from Android because they implement the same feature.
That's
yeah,
right.
the same teams implement the same feature, but in different ways. It's crazy, man.
Yeah.
And then you put some analytics, something like that, it's come worse.
Yes. Yeah.
Interesting.
Thank you.
Thank you.
Thanks, everybody. Lunch is outside.
Thank you.
with it, how things like to work on that. And links to my socials, etc., are at chris.swans.net. So what to expect in this 25 minutes or so. So I'm going to give an overview of the Mobile World Congress demo, what we took there, what we were trying to achieve with it, what we put together. Then this is a Flutter event, so I'd better talk a bit about Flutter. So we used Flutter for the front end of the demonstration, and it's a key part of the end-to-end character of what we're doing. Then move on to the Dart bits and how we ended up having to write a Dart device driver and what was involved with that and how much support we were able to get from the Dart ecosystem in building that. And then take a look at the connectivity, security, and privacy. And so how it all got put together from a network perspective and how we're able to protect people's security and privacy with these types of devices. I'll finish up with a review which will kind of reiterate these points. So an overview of the Mobile World Congress demo. This is where I cross my fingers and hope that video inside of Google Presentations actually works. So this is a video of the device I've got here. It's a Raspberry Pi. On top of that Raspberry Pi, there is a 4G LTE hat, which gives us connectivity. On top of that, a TFT. So we've got a local display. Connected to that is the sensor. This is a sensor for heart rate and oxygen saturation. And you can see in the video here, I'm putting my finger on the sensor and the local display is starting to read out the heart rate. So you can see the beats actually happening there. And zooming in, you can see as well now that the heart rate is being detected. And we've also got some oxygen saturation data going into the device. So that's all well and good locally, but the whole point of an Internet of Things is to get the data out of the thing and onto applications that connect over the internet. So here's a demo application for a doctor, and so we're sending the doctor the full set of data. So the doctor is getting the heart rate and the oxygen saturation, and that data is getting into the doctor's application end-to-end encrypted. So there's full privacy from the device through to the application user of that device. But we might want to share a subset of the data with other people. So in this case, a fitness instructor might have an application where they're signing in and they're only getting the heart rate, but not the oxygen saturation that would go along with that. So this is envisaging a world where people are properly in control of the data that's coming from their devices. We kind of got a tagline for that of your thing, your data. People might also want to share biographical data. So in this case, some maintenance might be needed for fitness equipment. And we can see here that Athletic Andy, as the owner of that equipment, is sending some data over to Mr. Tech Fix-It so that the Fix-It guy can come to the appropriate address and do the servicing. So that's an overview of what we put together. Let's move on to the next slide. So all of the code for this is open source. So the platform that we built this on is open sourced in @sign Foundation. And the repo for this particular code is @sign Foundation MWC demo. And inside of that, you can see the various folders on this screenshot of things like the receiver, which is written in Flutter, and which I'm going to come on to in a moment, and the sender, which is written in Dart. So that's actually taking data directly off the device and then packaging it up to be sent into the @signs, and then the receiver is connecting into an @sign in order to pull the data out of that. So I promised some Flutter stuff, and so let's take a look at the Flutter front end. So this is a screenshot from the sign-in part of the application from the Windows desktop version. So this is using the app platform. I'm able to sign into it using an @sign. In this case, I'm using my @sign at CP Swan. But if I didn't have an @sign already, the enrollment pieces are there, so people can sign up for a new @sign within the application. So this desktop version of the application, we predominantly used that as part of our testing, so that we weren't having to kind of hop around between devices while we were setting everything up and trying it out. We could just have an Alt-Tab to a different application on our laptops as we were doing this. The main screen you were just seeing in the video, so this is it without any data being received, just showing 0 on the dials, and that's the Windows desktop version. Of course, because it's Flutter, we could use the same application code across multiple platforms. So this is the version for Android, and there's a link in light blue at the bottom of the screen there to the Play Store where this application is live and you're able to download it. So using that repo I showed earlier, you could construct a redo of this. The full bill of materials is there, and you could stand one of those up and start sending your own data into your own @signs and get the app from the Play Store and get the visualization of that. And this was great when we were demoing it as well, because people could come along to our stand and we could get them to download the app over Wi-Fi, and they could then see data coming up on their own mobile phone. Of course, it's not just Android. We also did the same thing for iOS. Another link to the App Store there. We found this one actually surprisingly easy to find with search. So we called the app HRO2 for heart rate and oxygen. And there wasn't anything even vaguely like HRO2 already in the App Store. So this one comes straight up on the search, which is nice. And on the screenshots there, you can see that we had it running on iPads and on iPhones. And I think that's been one of the great things about using Flutter for this, was it was very straightforward to just build an application that worked across any kind of device that people would conceivably want to use with it. All right then, so I promised some Dart stuff, and onto the Dart device driver and what we had to do there. So when we embarked on this project, one of the people involved said, what kind of data can we get that people are going to be interested in and that will work as a demo at maybe a pretty small stand in MWC at Barcelona? And somebody came up with this. Let's get one of these sensors that reads out heart rate and oxygen saturation. And initially, this is the version of the sensor that was suggested. So a thing called the Max 3100. Turns out this is quite an old version of it, but you can pick these things up for about £5 on Amazon at the moment. And it appeared like there was lots of working examples of this. So if you did a quick search online, there were YouTube videos and samples and examples all over the place. So this looked like a really easy way of getting some data that people would be able to understand and understand what's happening with the demo. The way these things work is kind of illustrated from that snippet from the datasheet. So it's got two LEDs that shine up into the finger, a red LED and an infrared LED. It can detect the heart rate just from the red LED and the difference in reflectance that happens as the blood's pulsing past the sensor. And then the oxygen saturation, it needs both LEDs. So it's able to calculate oxygen saturation by looking at the difference in reflectance between the red LED and the infrared LED. There's a bit of an algorithm involved in calculating that, and that needs some calibration. So one of the things you find with these sensors is these kinds of packages, they're all just recommended for playing around with, not for full medical devices, because for a full medical device, it has to be properly calibrated to make sure that it's giving accurate readings. And this brings me to what I'll call the programmer's lament. We do these things not because they are easy, but because we thought they were going to be easy. And this turned out to be nowhere near as easy as we expected it to be. When I got to trying to use the code from all of those YouTube videos that I found, it became apparent that they'd all been faked. So beware. People will put together stuff, I guess, to be part of their online resume or whatever, where they haven't been properly diligent about making sure that it does what it says it does. So when I dug into what was happening with those demos and the associated code, they were reading the red and infrared raw data out of the sensor and presenting that through a bit of trivial maths to pretend that it was giving heart rate or oxygen saturation, but they weren't actually doing any of the calculations that need to be done to actually do that properly. So our quick and dirty solution to that was, let's get a newer sensor with better device drivers. And so that's the sensor that's on there now, the Max 30101. That's the latest version of this sensor. It's also got a green LED in it, which it can use for doing smoke particle detection. And it did come with better drivers. So the Python driver for this, which works with it on the Raspberry Pi, is very capable of reading out a heart rate, just not O2 saturation. And that was a bit disappointing because that wasn't going to allow us to show differential privacy between the doctor example and the trainer example if we didn't have two sets of data to play with. So what we ended up having to do was take the C++ driver, which is written for the Arduino, and we took some bits of the Python driver because actually there was some nice stuff in there as well, and we ported that to Dart. So this is a screenshot from the pubdev package that was published alongside of the open source. And so that's a Max 30101 driver implemented in Dart. And if you dive into the source code in the GitHub repo behind it, what you'll see there is pretty much a copy paste of a lot of the C++ driver code, because what this is doing is pretty low level. It's reaching out to the device, it's fetching numbers out of registers. Those registers are often reflecting stuff within particular bits. So we would have to set particular bits to configure the device, and then we would have to read out either bits or bytes in order to get the red LED sensing, the infrared LED sensing, and then take that data, put it into buffers, and take data out of those buffers and start actually running the algorithms across it. And within this driver, we were able to implement the heart rate and O2 saturation readings. Of course, like with most things, we stand on the shoulders of giants. And so we couldn't have written the Max 30101 driver without being able to actually connect into the device. And the device itself uses a protocol called I2C or I2C, which is a protocol which provides addressing over a single wire bus that allows multiple devices to be connected up to a single host controller. And so that's very commonly used in things like cars. And so if you look at how devices are spread around a car, there'll be a whole bunch of them on an I2C bus. So it turns out people had already created the underlying device drivers that we needed for that in the Dart periphery package. This is one of 2 packages that we found that are reasonably mature that have got I2C support. And my colleague, Gary Casey, who did pretty much all of the work on the Max 30101 driver, kind of picked out Dart periphery as having some of the characteristics he thought was going to be most useful in order to do that. If you go and look at Dart periphery on PubDev, you'll see one of the key dependencies of that is FFI, and it's through the fast functions interface that we kind of reach into C++ land and the underlying operating system calls that are made available there. There's quite an interesting article going around the web a week or so ago about C is no longer a programming language, or no longer just a programming language. It's kind of how we've come to define so much of the underlying APIs of the things that we use. And I think when we look at things like FFI, that becomes very clear. I've also got to congratulate the people that put together some of the C++ code. It was exceptionally well documented. I can't think of a single example where I've come across code that has been as well documented as this. So not just the code itself in terms of its readability and comments, but there's an entire blog post which runs through the underlying physics of how these sensors work and how they can be expected to read biometric signals. Then goes on to explain the algorithms and the mathematics of the algorithms in order to make sense of the sensor readings. And then finally, it gets to the code itself, which is implementing those algorithms. And so as we were going through building the Dart version of this, the C++ reference really provided an excellent example to work from. And that helped us on our way to getting a working device driver. Also, the data sheet for the device itself. So that's what the manufacturer gives here. It'd be great if the manufacturers actually shipped working code for popular programming languages, but they don't. They ship a data sheet, and people are expected to figure it out from there. So on then to connectivity, security, and privacy. So the key thing here is end-to-end encryption. And this is a bit of a complicated diagram, I realize, but there's a few moving parts here. So on the left-hand side, we start off with the device. So that's one of the ends of our end-to-end. And if we're going to do an end-to-end encrypted conversation, then both ends need to have keys, and both ends need to be able to talk to each other. And it's very difficult to mediate direct point-to-point connections for that kind of thing. So as we've been doing this demo stuff, we've also been working with a medical devices manufacturer, and their great complaint is connectivity is a nightmare. They're trying to put real devices of this kind of nature into people's homes, or that they're going to take on the bus with them, that need to have connectivity over Wi-Fi networks and mobile networks, but then needs to get data into secure systems for patient records within hospitals. And so that then results in lots of trouble with VPNs, etc. So the way we get around this is by each end having a proxy which can be run in a choice of locations. So by default, we run those proxies in the cloud, but they can be self-hosted and run pretty much anywhere. And we call those secondary servers. So the IoT device is sending data to its secondary server, and the receiving application on the handset is getting data from its secondary server. And then the way that this works to create an end-to-end secure system is the IoT device knows which @ sign it's going to be sending data to. and which @sign it's going to be sending data through. And so it first connects to the @sign it's sending data through, which is the IoT secondary, and says, can you get me the public key for the @sign I'm sending stuff to? I'll reply with its public key. At that point, it can then start encrypting data for the receiving application. And so it'll send that data to its secondary. Its secondary then notifies the receiving secondary that that data is available. Receiving secondary picks it up, and then the receiving application is able to get the data. The neat thing about this is it means at both ends, from a network perspective, the communication is outbound to the secondary servers, and we're no longer messing around with having to punch holes through firewalls or VPNs or any of that kind of stuff. So net upshot of that is we can take data from a sensor and have it flow encrypted all the way to an application, and we've got control over which receiving application, which identity is getting that data. So nearly a question time. A quick review then. So I gave an overview of the Mobile World Congress demo and how we put together this demo device and a set of demo applications that this device could send data to and people could kind of interact with and see what was happening. That demo application, we used Flutter to create it. So a Flutter front end that people could see data coming into. And because we used Flutter, we were able to run that on Windows and get versions of it into the Play Store and App Store in time for the event. We'd hoped that the devices we picked were going to just work with the Raspberry Pi, and that we'd have an easy source of heart rate and O2 saturation data, and that turned out not to be true. So we went on a little adventure and had to write a Dart device driver, but it turns out Dart is a really good systems programming language and has got the right kind of C++ heritage for us to be able to take code that's been designed for Arduino type environments and written in C++ and fairly trivially manipulate that into being Dart code that we can run on the Pi. And then in terms of connectivity, security, and privacy, we're taking that sensor data and sending it into @signs on the app platform, which is giving us end-to-end encryption from the device all the way to the receiving application. So there's two ways that this demo ended up being end-to-end. We were using Dart all the way through end-to-end, and we were using encryption all the way through end-to-end. So thank you for your attention. If you want to contact me later on about anything I've been talking about, I'm Chris at @sign.com, and you can find me on most of the platforms as @CPSwan, and that is my @sign on the app platform. If you want to get started with the app platform, there's a ton of resources. So @sign.dev is where to start. @sign Foundation on GitHub is where you'll find all of the code for the MWC demo that I've been talking about. And we've got a Discord community of many people that are doing interesting things with this stuff. And we regularly get involved in hackathons and that sort of thing. So there's a lot of activity going on. So thanks for your time, and I'm happy to answer any questions.
What's next?
What's next? So I mentioned sort of almost in passing the medical devices company. So we shared the source with them before we'd actually open sourced. And so as we were showing off this kind of clunky, not suitable for medical purposes thing at Mobile World Congress, they've got now an internal proof of concept, which is a real medical quality device sending data into an actual patient record system. So I think what's next for this kind of thing is some real world applications for medical devices and associated data. But that will then get us into medical device certification cycles, which are prolonged and demanding from a sort of test coverage perspective and things like that. So we're also looking at other IoT use cases, which don't have quite so much regulatory obstacles in the way in terms of getting stuff to market.
Are you talking in terms of these applications or the source of data, choosing where it wants to send the data, or the consumer looking through and requesting answers?
It can be both, but I think if we're going to be true to this notion of your device, your data, then my expectation around that is devices will come with management applications where people can choose which data are being sent to which at-signs, and from there, essentially who has access to it. And so, if you take the medical device example, the natural thing there is it's going to be sending data into the healthcare provider and their associated patient record system. But even then, there's kind of multiple opportunities for data to be appropriately shared with other third parties. So if you look at things like drugs trials are mostly now conducted by specialist agencies whose kind of job it is to run trials and gather data. And so, of course, those companies are going to want to pair up with the healthcare providers to be able to tap into the data. But we're now in a position where the patient has kind of full consent and control over that, rather than data disappearing into black holes and being shared behind the scenes. And I know that all happens with proper concern for sort of written consent and contractual frameworks at the moment, but that's often very opaque to some of the people involved. So I think we can get better transparency about where data is going and which purposes it's being used for.
I was thinking more also from the side of privacy. If you can browse the catalog of available data and request it, then you've given away what type of data is available as well.
Anybody else? All right, well, thank you.
Thanks, everyone.
Thank you.
So today I have very interesting talk about Flutter, an amazing framework, very interesting cross-platform application development, and today I'll tell you how to take your applications on the web and why to take your applications on the web. So a very brief introduction. I'm a senior associate at JP Morgan, a lead at GDG Glasgow. I primarily work in JavaScript, and I like to code in Flutter as well. So here I am today to talk about Flutter on the web. Okay, Flutter, fantastic framework, as I told before. So you can build mobile applications, you can build desktop applications. Now the support is there for Windows, Linux, Mac OS. And about a year back, the support for web went stable, I think somewhere in March 2021. So with that, you can actually build the applications on mobile devices, desktop environments, as well as on the web. And because of that, this particular framework, Flutter, from fantastic to became amazing. I'll tell you why. So Flutter Web, the question is, most of the users, they have got mobile devices. If they're not using mobile devices, they are using laptops. And they would want an application which is very native to their platform or operating systems. However, why we need Flutter Web? So despite having everything in their mobile phones, in their desktop environments, the web still has got a huge user base. So I know a lot of people, take examples of senior citizens, they're not very used to, very familiar with the apps, and they still, whenever you have to do something, they still go to the Google, search something, and they look for a browser application. So web still has got a huge user base, and you should be using that. Now, with Flutter on the web, you have the same framework, you have different renderers. So it's not like you'll be using a different code base or you have to do anything explicit to make your applications available on the web. So it's the same code base and your reachability just gone from on-the-go users to the browser users as well. Now, why you should be choosing Flutter for web development? Because web is very versatile environment. You have lots of other frameworks available. You have lots of other tools and technologies available to build your applications. React, Angular, Vue, JavaScript, just to name a few. However, why Flutter? The main reason is the prototyping is really rapid. Why? Because you're writing a piece of code, you can immediately test your code on a browser environment, whether it is working, how it is looking, how it is working there. I will come back to the caveats later, but that's the benefit of it, that you are writing one application, same code base, you are able to test on mobile devices, on desktop environments, as well as on the web. So that's really fast, rapid prototyping. And with the Flutter tools and the Flutter compilers, the development part is really, really fast. Next part, looks-wise, amazing. Why? Flutter has got some of the beautiful UIs, UI components already built, material and iOS-looking applications. So you basically can implement any of the plugins, any of the frameworks. And as you have the same code base, you don't have to write anything else. So you don't have to think about, okay, for this application, I'm going to use Tailwind. Or this application, I'm going to use Bootstrap or anything else. You don't have to think about what component library you're going to use. You'll be using the same exact component library that you're using for your mobile application development. So the looks, the feels, the animations, everything is so native, and you will feel amazed by that. And all of this without losing the performance. How? We'll come back to that. When you should be considering Flutter Web and when not. First of all, Flutter is for web application development, not for website development. So you should not be using that. Considering whenever you build websites, you actually think about SEOs. So as it's an application, it's generated dynamically in the runtime, it is not SEO optimized. So you should not be using Flutter in case if you want to build static websites. Okay. The next part, where you can exactly use it, like if you are building progressive web apps or PWAs, if you're using single page applications, consider you're building an application using Angular or React, the same thing can be done using Flutter Web. Or let's say you have already built an application using Flutter for your mobile devices or for desktop environments, the same exact thing you want to port to your web users, you can simply prototype that using Flutter. To do that, you don't have to do anything. You simply have to add the web support in your Flutter applications and you are good to go. How? So this particular command, I don't think if you have installed Flutter recently, you have to do that because the stable support for web went live last year. So in case you have not worked for last 1 year on Flutter, you should be doing that. So what you can do is you can simply do Flutter channel stable, means you are telling Flutter that, okay, if you're using Flutter beta or Flutter alpha, you can simply move to the stable channel. And then you can simply say Flutter upgrade, and what it will do, it will download the latest stable framework and the code, the Flutter toolkits on your local machine, and you are good to go. Next part, the moment you have Flutter web toolkit installed in your local, and if you run Flutter devices, you should see at least one device listed, which will be Chrome. Okay, so Chrome doesn't mean your Chrome browser. Chrome means as a device here, means your Flutter toolkit is web enabled. You can build applications for the web and you can test them. Okay, now if you have not built an application in Flutter, so means you are starting your prototyping from scratch, you can follow the first part, Flutter create app. The moment you create an application, Flutter generates the boilerplate code for you for all possible environments. So let's say if you're working on a Mac device, it will generate folders for iOS, for Android, for web, as well as for your Mac OS. If you're working on Windows, there'll be an additional folder called as Windows. If you're working on Linux, there'll be a folder Linux. All you are looking for is your web folder. If it is there, it means your application will be supported for web as well. If you already have an application developed and you want to add a web support, what you have to do, simply inside that directory, run the command flutter create dot. It will run the channels, upgrades, codes, and it will generate web folder inside your application without deleting anything. So your web support is there, and that's it. You're done. Now, web renderers. What are these? So if you look on the left side, we have the initial engine or renderers for Flutter, how the Flutter actually works on different platforms. So when web support was first thought that, okay, we will be supporting web in the Flutter, what happened is the core framework remained the same. So if you see on the left side, on the right side, the top two parts are exactly the same. The only thing which changed is the renderer, how these things are actually ported to the native libraries to render the application. So on the left side, that's for your mobile devices and for your Windows applications. So the engine is Kia, dot, and text. And when you go to the web, the major renderer for web is JavaScript. So what happened is people at Flutter, because they tried to port the Dart code using Dart to JS compiler into a JavaScript file. So what happens is whenever you write your code in Flutter, whenever you add the Flutter, whenever you run the Flutter web build, it actually converts your Dart code into a JavaScript code, which will then be executed on the browser platform, and your application will immediately become a browser application. Now, with web renderers, we have two different types of renderers available. So when Flutter team started working on Flutter web, they started with the HTML renderer. So HTML renderer is basically whatever you are building, or whatever UI components you are generating, they will be rendered using HTML, CSS, and Canvas API. Now, as HTML, CSS, Canvas API, they are really, really small in bundle. The output size of your web application will be relatively really, really small. It actually supports the native browser text rendering. However, that creates a lot of problems. The problem is, so if it's not like the problem is if you're building a text heavy application, you can simply see that, okay, this piece is not getting rendered properly. However, as Flutter rendering is converted from Dart to the Canvas API, sometimes you might feel that the text is not as it is supposed to be, specifically if you are moving from one browser size to another, if the user is resizing the browser, if you're moving from laptop to desktop or really high dense graphics monitors. So there, the text layout will be distorted. So that's when Flutter team, they started porting up Skia, which is the actual renderer for mobile and desktop environments, using WebAssembly, and they ported that as a Canvas kit. So now the exact same application, in exact same way how it was getting rendered on the mobile devices, exactly same application will be rendered on your browser environment. So there'll be absolutely no discrepancies, no difference between how you see an application on your mobile phone, on your desktop environment, on your web environment. However, it comes at a price. The Canvas kit, it becomes larger when you bundle it. Now that difference between the size is about 2 MB. So on a desktop environment, it doesn't really matter. 2 MB is nothing for a desktop environment. However, for a mobile environment, it's a lot. So if you consider your users which are living remotely, they don't have that kind of network bandwidth, considering Canvas kit for your web renderer will come at a cost for you. Okay, even though your application will look amazing, the initial load of the application and every refresh will come at a cost. Now, with Canvas kit, as we are not dependent on native browser rendering, the application becomes completely browser independent. Means no matter where you are using it, you will see exact same look and feel everywhere. Okay, now the next part, plugins with Flutter Web. So this is what you have to consider. Imagine you already have a built-in application for mobile devices, you are using some plugins, and before you go ahead and you port your application to web, you have to stop and you have to think that whether your plugins that you are using, they are supported for web platform or not. So for that, you can simply go to pub.dev, you can look up your plugin, and plugin actually lists what platforms are supported. As long as you can see the web is there, you're good to go. Because with Flutter, if we go back a few slides, if you see here, the only thing which is changing is that we are adding a new device or a new platform for the rendering. The Flutter framework itself or the Dart framework itself is not changing anywhere. The only device which is getting added here is web. So just the way you are adding a device as Android or iOS or Mac or Linux or Windows, web is also just a simple platform. Now, plugins are platform dependent because you might be using some functionalities inside the plugin which are related to iOS system, which are related to Android system. If you are using those kind of plugins, you should think that, okay, whether you have an alternative for that plugin available which supports web as well, or otherwise you will have to think that how you can have a fallback API or a fallback code written so that if that particular plugin is not supported and the user is running on the web, how you will be able to do that. Now, to do that, what you have to do is you have to simply run a platform check. So with Flutter, you have a variable exported called as k-is-web in the Flutter foundation.dart. Simply import it, and then you can check if the current platform is web or not. So imagine you're running a plugin to render the images. Okay. Now, that particular plugin is not supported for web. So what you have to do is you have to think that, okay, this is not supported. How will I render the exact same functionality in my web platforms? So we have to write something called as fallback. To do that, we'll be using this exact same code. So just check if it is a web platform, render the fallback code. If not, go ahead with the regular implementation. Okay. Next, mobile devices, really small. Desktop environments, browser environments can be small, can be big. Okay. One mobile device, it has a width of like what, 400 pixels or so. A desktop environment generally comes with 1100 or 1200 pixels. So that's a huge difference. So if your application is built considering mobile devices in the mind, then your design will not be compatible with desktop or laptop environments. So what do you have to do? In this case, you have to do something called as adaptive layout. So let's say you are rendering a list. So you can think about rendering the list in multiple columns, maybe 2 columns, 3 columns, whenever the size grows as per the screen size. When you are rendering that in a tablet environment, the size will be about 700 pixels, 800 pixels. You can render 2 columns. If it grows even bigger, you can render 3 columns. To do that, what you can do, you can use 2 things, either layout builder or media query.off function. So layout builder actually is a class where you have, I should have, okay. So I don't have a snippet here, but what happens is with layout builder, you define a builder where you will be injected with a context, the build context, as well as the constraint, your box constraint class, where what happens is the box constraint tells you the max width, the min width of the device, and other, maybe you can detect the orientations as well. So that way you can determine what exactly you have to render. So just check if constraint.max width is more than 700, means you're on a desktop platform, render 2 columns, or render 3 columns. Okay, so based on that, you can actually make your applications be adaptive to different environments. Okay, and I have a very small showcase. I was really amazed when I saw this particular application. Okay, so this is no, it's not letting me.
Is it a time?
Okay, I can share this one. I'll quickly switch. Yeah. Okay, so when I saw this, I was really impressed the way the UI looks for a web application. So this is, you can visit this. This is gallery.flutter.dev. It's a web application built in Flutter to showcase the power of web. Now, if you say this entire user interface, this is built in Flutter. You can click compose, type in, I mean, it gives me exact same look and feel and behavior of a mobile application, which you can use on the go. Not only this, if you go back to the other demos, Shrine, next. So these are just some of the cool things built with Flutter.
Do they have the source code available?
Yep. So if you visit gallery.flutter.dev, you can actually see the source code available, and you can find out what they have done. But they actually really used 2 of the platforms. So if you see downstairs, Material and Cupertino for iOS and for Android look and feels. And they actually have a lot of features which, if you plan to build in web applications, you will have to spend a lot of writing CSS, styling, and animations. Whereas these things are already available in Flutter. These applications were once a Flutter application, and the Flutter team deported them into web. So if you want to explore them, it's really amazing. Okay, I think that's me. Any questions?
This is a surprise. A good question wins the bottle.
Sorry, Mark.
Yeah, go ahead.
I have one question. Because you've done a lot of JavaScript work in the past, I find it interesting. I used to do a bit of JavaScript as well, and React Native. When I went to Flutter, my experience was just if I would categorize vaguely, it was just nicer. But there is hot reload in React Native as well, and basically and there's even other things that Flutter doesn't have, like code push.
Yep.
And for some reason, I find myself liking Flutter more, and I can't explain why. When someone says we have React Native, it's more established. I can't justify it, but I just enjoy it.
Okay, to me, I love JavaScript, but still I love Flutter more than React Native, and honestly, I can't explain why. So the thing is, one of the most beautiful thing about Flutter is the community support. With React Native, they have one documentation available. You start following them. For some reasons, I feel that they stopped making it more comfortable for newbies to start working on, because after sometimes they handed it over. There were a couple of other companies like Expo. They started pitching in and they started building on top of everything. And then React Native documentation, they adopted Expo instead of their native scripts and all. So I think they delegated their development part to somebody else, and that's how I stopped using them. But with Flutter, still growing, brand new, and they are actively supporting new features into that. And the other thing is, every feature about it is very stable. If you have to build an application, test an application, you don't have to leave the environment, the coding environment. With React Native, what I felt was you have to set up Expo first, then you have to go back to writing React Native code and come back. And honestly, if you don't know JavaScript well, you will have to come back to React Native after your JavaScript foundation is complete. But the one problem with learning JavaScript with a lot of developers was they didn't find it as native to them, because they came from object-oriented background, and JavaScript was really too much for them to understand. So React Native, it tried to bridge that gap by using TypeScript and ES6 features, so that Java developers or other .NET developers, they could relate to that. However, it's still JavaScript. And a lot of pain in JavaScript when you start learning and you don't know the foundation. So Flutter, I like it a lot, because I could do a lot of things without leaving my development environment, honestly. So
Well, can we combine both of them together? So have some code in JavaScript and some with Flutter. So basically.
So honestly, yes, you can, because Flutter, when you build the Flutter code, Flutter web, it actually generates a JavaScript document. And what you have to do is, there'll be an index.html. That index.html will be importing your .js code. So modify that particular JavaScript file. Or maybe you build up, let's say you have an application already built up in PHP or in Angular or in React. All you can do is, after that is hosted, use an iframe to render your application, Flutter application, into that iframe, and you're good to go. Yep. Yeah.
Well, first off, for me, it's not having to do with CSS. That's the big thing for me. Two things. You mentioned Canvas Kit.
Yeah.
Is it rendering just as well outside of a Google browser as it does inside of a Google browser?
actually browser independent. It doesn't matter where it is rendering.
Right,
So Canvas,
no more of those only compatible with Chrome.
no, you don't have to. No, because as I mentioned before, Canvas Kit is built using Skia, which is the graphics engine, and it is open source as well as cross-platform. And it's the same graphic engine which Flutter uses for rest of the application environments. So for Android, for iOS, for Windows, exact same engine is there. Now, the same specific engine with the beauty of WebAssembly has been brought to web using Canvas Kit. They have renamed it to Canvas Kit. So Canvas Kit is essentially your mobile development environment or rendering engine plus WebAssembly. So it is completely browser independent. Doesn't matter which browser you are using. If you build your own browser, you can expect it to be supported there as well.
Thank you. The second one is you showed K is web.
Yeah.
But then you also talked about screen size as well.
Yeah.
Would you not just use is screen size to decide?
Based on screen size, you cannot tell if it is specifically a web environment. No. A web environment can be small on a mobile browser. A web environment can be large on a desktop in space. How will you determine if it is a web platform? So if the application is built using web, Flutter as a web application, you cannot define that with the max width or the box constraints. You cannot
You need both, that's what you're saying.
When we talked about the adaptive layout, so layout builder dot max, the constraints part or the media query, those are specifically only if you want to determine what's the screen size and you want to adopt your UI using that. But to determine if your platform actually is web, you have to use that particular variable. And interesting thing about that variable is it actually checks whether so in JavaScript, how many of you do you know that JavaScript doesn't know integers? JavaScript doesn't know integers.
What?
And because of that, the Flutter team, they were able to actually check whether it is web or not. Because browsers, they don't understand integers. Yeah.
Is Flutter Web going to be supporting SEO anytime soon?
I don't know about that, but I highly doubt that. Reason being, as I mentioned before, it is meant for web applications and not websites, and they still don't have the server-side rendering support. But I would not rule that out that okay, they will not build it. They might build it because they built server-side rendering for everything else. So it is just expected. It's just about time when they release it, but they should be. Yep.
I think the gentleman here is taking notes and gets the bottle.
Some water.
Thank you.
One per customer.
Okay.
Yeah, I think that's it. Yes.
That's me. Thanks, everyone.
So we're actually running a bit ahead of schedule. So if you want to grab a drink or go for a bio break, now's the time. While I set up.
Hello, everyone. When you went to uni, I spoke
Okay, thank you for coming. I've just been, I started the Flutter community with a few other people, and we're just trying to keep it going and help everyone. Today, we're going to continue this kind of second part to a talk I gave at Flutter Vikings, which is about 3D and Flutter. So I'm going to go over some of the basics I covered in there, just so that we've got common ground. So Wipeout with Flutter. I don't know how many of you have heard of Wipeout. It was came out in 1995, I think. So yeah, if you were born after that, I'm afraid you've never heard of it. What we're going to be talking about, I'll go over that in a minute. We're also going to talk about the original game and what it is on the PlayStation, how we do rendering in 3D with Flutter, how we get around some of the limitations of the Flutter platform as it is right now, what I've done to reverse engineer the current game, how we recreate it, and then finally, what is the future for 3D on the platform. I will open up the floor to general Flutter questions at the very end if there's time, so I have to answer all your questions. So, rendering in 3D, working on recreating Wipeout. So I gave a talk in Flutter Vikings where I spoke about rendering in 3D. Specifically, that was to do with Resident Evil 1. Resident Evil 1 is quite a nice target for rendering because the only thing it renders in 3D are the characters. All the backgrounds are 2D and they just look 3D. I needed something that I could test the performance of the engine with and kind of push more out, and I wanted a fast-paced game. Wipeout is that. So hopefully this does work. This is the game. I don't know if any of you have seen this before, and I'm actually going to show it running hopefully in a bit. But first, the PlayStation. I just want to cover a little bit about this. The original PlayStation, I forget when it came out. 92, 93, I think. It was a while ago. It has a 34 megahertz processor. Yes, so it's so powerful. 2 megabytes of RAM, and I believe an extra megabyte of VRAM that is accessed through the same bus. So it's complicated. Anyway, the three parts that we care about if we're going to do 3D rendering from the original are these three: the GPU, motion decoder, and specifically the geometry transformation engine. So the geometry transformation engine, there's some limitations on the original platform, and the original platform does not have Z buffering. Z buffering is about the depth and about how you detect which pixels behind each other pixel in a 3D environment. So all it did is render the 2D triangles in a rendering order, which guaranteed the ones behind were painted first. We'll talk about this a bit more later on. So the key here is to, sorry, I'm getting ahead of myself. I only rendered 2D triangles. So all those 3D games, they're only done with 2D triangles. I'll explain a little bit more about that as we go. So I also use fixed point math. For fun times, if you ever try and play a PlayStation game now, all the edges of everything wobble. That's because it's done with fixed point math and not floating point. Where's JavaScript when you need it? So, so the geometry transformation engine is actually a little part of the little chip on the board, and that actually does matrix multiplication, perspective transformation, and all the things listed here. The point of that is to offload the tasks to the hardware from the CPU. The CPU only 34 megahertz. We need all that power we can for the game to do the game logic. So the more we can offload to separate co-processors, the better. So that's what we get from the geometry transformation engine. The motion decoder or macro block decoder, depending on who you are, that actually it was quite phenomenal at the time. That is full motion video. Full motion video was one of these FMV sequences. I don't know if anyone remembers when they first came out in games. It was, oh my God, it's like a movie. It was amazing. Well, the thing that actually made that happen is the motion decoder. It actually runs on the bus alongside the GPU, and it sends blocks of 8x8 pixels to the GPU. There are configurations that this works in. It does 24-bit color. So even though games may not run in the full color depth, videos can. It's interesting to know that if anyone cares, this is a bit archaic knowledge, the bus between the video RAM and the GPU is 16-bit. It's actually two 16-bit channels, which means to get the best performance, you're better off doing 16-bit color, if you wanted to know. And then the GPU, and as I said earlier, the GPU can only actually do 2D triangles. It can also do lines and some other basics things, but whenever you try and draw a rectangle, it's actually two triangles. There's also, the actual GPU does support sprites. Funny enough, the sprites are actually quads, they're actually rectangles. So it just does them in two triangles. So everything comes down to triangles. The original game. So let's see if I can make this happen. Do you know what we're going to do first? I'm going to see if the audio plays through and play the game intro, hopefully. Hopefully. Fingers crossed. This might bring back some memories. This might be completely off topic if it loads. Please? I guess not. It's buffering.
Please coming back to the good old day Wi-Fi too.
I'll give it a few seconds. If not, we'll carry on. Do you know what? Do you know what we'll do? He's going to play. No. It's all right. We have a backup plan.
Should we play?
We actually are going to load the game up. Hopefully. Hopefully. So I was just going to skip straight into it, but I'll reset just so everyone gets the full experience.
Have you only got 2 megabytes of RAM?
That would be the problem, right?
Yeah.
So hopefully the audio comes through. If not, we'll have some. No, it's only going to come through the laptop. Well, there's not much to it. So, do I want to skip this? Oh. It's only a few. Oh, that is really, really bad, isn't it? It's nice and smooth on here. Oh well, I think we'll skip that. So, let's see if this loads up okay. I think I must have like the worst Wi-Fi in the room for some reason. I don't know. Works fine for me.
So this is the PlayStation game.
This is the PlayStation. This is not done in Flutter. I'm going to caveat that right now. We will get there. I just want to show what we're aiming to get to for those that haven't seen the game.
Is Windows your preferred environment?
It is indeed, yeah.
Okay.
Mainly because I started off doing Windows development, so it's fine on here. This is like the Wi-Fi. It's just the Wi-Fi. So there's actually you're actually controlling shit flying around a track, and so on. I'm not going to like bore you guys with the game because it's coming through at like 1 frame a second. This is ridiculous. Anyway, well that goes out there. It looks good. Anyway. Right, let's get back to the slide and see how far we can go. God, come on.
Do you also have a Mac for iOS stuff?
I do indeed, yeah. I actually have a MacBook Pro and a Mac Mini. M1 Mac Mini. Some awesome stuff. This is the Wi-Fi. As much as I'd like to blame Windows, it's not. Right. No. Oh God. This is all breaking right when you don't want it to. There we go. Okay. Come back to life. Hopefully. Sorry, guys. Yeah, that's right. Yes. Well, we're going to be talking about rendering 3D in just a moment. There we go. So I'm going to take you through a few of the basic concepts. Also talk about what the GPU actually does and what projection is. These are all quite important techniques for where we're going to go. So first of all, 3D basics. So what you see on the left-hand side is a model from Resident Evil that's actually rendered right there in Flutter. The yellow points are vertices. Vertices and vector normally used interchangeably. Basically a point on the 3D model. It can also be used to point in 3D space for a game. And points to things to mention. So 2D vectors, probably what you're used to actually. So if you look at the position of a widget in debug, in Flutter, you'll see an X and a Y and a width and height. These are 2D vertices. They also have an origin. So on Flutter, the origin is top left. This is normal for desktop and GUI UIs. For 3D, it's normally bottom left. So that might catch you out. So normally you scale on a -1 to flip it around. 3D, all it is 2D with an extra dimension, funny enough, in the Z axis. And if anyone's curious, is this, if the images load, yeah. So if you can do that, that is X, Y, and Z in that order. So that's how you know Y is always up, X is always horizontal, and Z is always the depth. That's called the left-hand rule. There is the right-hand rule, which is funny enough the opposite. When we're dealing with 3D models, they're actually built up of these vertices. They also have a series of edges, and those edges combine together to make the faces, and faces make polygons, and so on and so forth, as diagrammed here. The key point here is that we don't really care about surfaces and polygons. We only care about triangles. Normally. We'll get to how this works in Flutter a little bit. So when you have a 3D model, there's several triangles will have the same vertices as on one of its edges. So the way to compress that is to have a separate vertex list and then in this case, diagrammed face list, but it's also called indices. And that's the indexes, that is literally 0, 1, 2, 3, the index into the vertex array. And this allows us to sort of reuse those components and slightly compress the data that we're sending. Also to mention here is triangles have a direction that they're facing. The engine that I'm working on, and most 3D engines have what's called back face culling. That is things that face away from the camera, while the camera can never see them, so they're removed from rendering. So it's always important to understand the clockwise and counterclockwise rotations. So normally clockwise is facing towards the camera and counterclockwise is facing away. You can, however, do your 3D in either direction as long as one is facing the camera, then you'll see something. And that's another little diagram of what this cube and its vertices look like. What volume is that? What the GPU does. So it's kind of interesting. So what you see on your computer screens is actually 2D, right? So it doesn't matter if you've got a 3D graphics card, you're still going to see 2D. And even when you have an Oculus Rift and all the rest of it, it's 2D images and stereoscopic, right? Like at the end of the day, 3D is all in your mind. The point here is that the GPU's job literally to draw the pixels. So it takes what 3D information you've given it to draw two-dimensional colored pixels. And that is literally what's called the GPU pipeline. as you can see pictured here. So from a Flutter perspective, we don't have access to the full pipeline. Skier does. Skier is what renders all those lovely pixels that Flutter does. We could go about rendering every single pixel ourselves, but it'd be terribly slow. That's what the GPU is for. It accelerates the rendering. It's a bit like what I said at the very beginning with the PlayStation offloading to a coprocessor. The point here is that we send the data to the GPU, and the GPU does the rendering. We'll just point out here in bold, vertex shader and fragment shader, you'll probably hear in graphics. One is about taking input 3D points and output some changed 3D points. This is how you get ripple effects and other things. And then the fragment shader is about taking those vertices in and rendering out the fragments, which are essentially parts of, they're not necessarily pixels themselves, they can be larger than pixels, but they are essentially pixels if you think about it that way. It's a simple way of thinking about it. There's also a term texels, which is texture pixels, and that's a whole other thing. So, as I said earlier, 3D is in the mind of the computer, right? Like we see 2D. So what we're actually trying to do is projection. That is basically taking 3D coordinates and using a projection matrix. That is just, the system we use is homogeneous coordinates. It's a matrix multiplication, matrix math. I won't go into the details, but basically means that we can take those 3D coordinates and project them onto a 2D plane, as pictured here. There's also a three-point projection down here, which is essentially the way that we get in Flutter. It's a 4D matrix. We'll talk about some limitations of Flutter in a bit, but what we're actually going to be doing and what Flutter does is called the painter's algorithm. So you'll notice that little something you can try in Flutter if you're interested. If you have a column or a row, and you have a set of widgets in there, they're painted top down. So the first widget in the code is painted first, the second widget is painted next, and so on. That is the painting order. You can actually reverse that order. So there's actually a parameter on row and column called vertical, a note on column, it's called vertical direction. And if you set it to up instead of down, it renders from the bottom one first, going up. This can actually sort out some things when you have a shadow on front of, you want to get a shadow in front of something else. But that's basically what this is. So if you look at the bottom pictured here, it's you paint what's at the back first and paint what's in front. Now, it's also worth mentioning here that in the diagram here, the trees, they're painted on top of the background, which means that's pixel overdraw. Probably heard of that. You don't want that. That means your GPU is painting the same pixel multiple times into the pixel buffer. So how do we use all that information to render stuff in Flutter? So the options for rendering 3D in Flutter. So from a mobile app perspective, you're better off Unity 3D. It's a pre-made engine, works. It'll give you a view into your 3D space. There are several OpenGL plugins, and there's several being developed by the community. Currently, right now, if you're using Flutter Web or just pure Dart, that also works, you can actually use WebGL. So Dart has always had WebGL support, away from way back when. So you can currently go make WebGL applications in Dart. And what we're going to do is the most insane approach, which is use pure Dart and Flutter. And we're going to take advantage of 3D of the hardware acceleration, but for 2D triangles only. So from day one, Flutter has always had this method. It's called draw vertices, and it's been there as far as I remember from the alpha days. And you give it a vertex buffer. That's this. This is what's displayed on the right. Sorry, it's a bit small. You give it a vertex mode. Several of those. Normally, the default vertex mode that you probably want to go with is triangles. Well, no, that's what it is. There's also triangle fan, and a few other things that push straight over to the underlying hardware to optimize things. If you notice, the positions is offset. Offset is 2D. So this is how you basically give it a list of those vertices in 2-dimensional coordinates and a list of the texture coordinates for those 2D vertices. Also, you use vertex colors, which is quite handy if you're trying to do like coloring, shading. And then finally, the indices, and that is the list in which it will render those triangles with. So that sort of harks back to the 3D basics. And this is how I'm rendering with 3D. So half the trouble, and if you go back to, if you think back to the beginning, we talked about that geometry transformation engine. That's the bit of the original PlayStation that did all the complicated math to make 2D triangles. As I said, the hub acceleration, the GPU only renders 2D triangles on the PlayStation. We are going to take advantage of the fact that we have faster CPUs now, and we can actually use this library, Vector Math. This has been made by the Dart team, and it's also included as Flutter. Flutter actually uses this for all of its drawing and so on, so there's no overhead. And you can do 2D, 3D, 4D, and so on, and it's fully documented and well tested. Go explore it. It's kind of interesting. Another interesting point, it has collision detection. So that's brilliant for when you're making games. Standard stuff. I will mention, this isn't, like, I haven't come up with this myself. As I said, that draw vertices has been around since day one. And it's, I first noticed it quite some time ago when I was playing around rendering some cubes and some various things in the beginning days. But what got me interested back in doing 3D is when this chap, Victor, he made this Flutter clock for the Flutter clock challenge. That is 3D rendered. That's the source code. You can go look at it yourself. It, however, is terribly slow. So it's nice to see. It's a nice output, but not very performant. But it's interesting. It's got transparencies and lighting happening in there. Quite cool. There's also G Skinner. They did some Flutter vignettes, and in the little animation here, you can see three-dimensional objects, use some fancy inversion effects, and so on and so forth. And again, they wrote a blog post on how they did that, and the source code is openly available. So, getting back to where we were. 2D triangles only. It is a limitation. However, we are taking advantage of hardware acceleration when we're rendering. It is no 3D hardware acceleration. So in the future, I'd like to see the team actually expose a 3D draw function from the canvas. There's no reason why they couldn't do that, I don't think. Again, though, the reason why they push back on some of this stuff in the Flutter team is that whatever they change at that level has to be included in the Flutter engine, which is a binary that's shipped with every app. So you may not use the 3D, but the 3D is there. So every little byte counts in that. I think it's about 4.5 meg at the moment, the runtime for Android. If you do like a desktop app, it's like 15 meg. It varies, obviously, depending on the platform and so on. But yeah, you don't want to be shipping suddenly a gigabyte because you want all these extra features. This is why they don't give you all the Skier features, because Skier is about 30 meg. So, compile. So, it'll take its space. And the previous talk that spoke about Flutter Web shipping Canvas kit, that is why there's a big lump of a binary that comes down as part of your thing, because it supports a lot of rendering. So 2D triangles only, great. No Z buffer can cause Z fighting. So this is what's pictured here on the left. That's Z fighting. You see it in 3D games and various things. When you have two three-dimensional planes that intersect each other, and it can't decide which one is should be correctly in front of the other. They could be very minusculely, a hundredth, of a sort of degree off from each other, and you get this kind of weird effect. This effect here is actually because there's rendering fragments. On Flutter, you'll see it renders one triangle in front of that, because again, we're rendering 2D triangles. We have to choose that drawing order. This is exactly the same as the original PlayStation. I will show you a demo in a minute of this in action, and you can see what I'm talking about. It's not noticeable, and for example, if you've ever played a PlayStation game, all games have this problem. If you've never really noticed it, then you haven't had a problem. That draw, as I said, we're using the draw vertices command on the canvas, and in doing so, it renders all of the three-dimensional points that you gave. All of the 2D triangles that you've given it all at once. Well, if you want to render multiple objects, they're going to be rendered in that painter's algorithm back to front in the order that you call the draw functions. This has a limitation. That means that we have to draw all of the 3D objects at the same time. So again, slightly more heavy on the CPU than I'd like. Maybe again, if they support three-dimensional coordinates and Z buffer, then we can just shift those 3D coordinates over to the hardware and it can do the job that it needs to do. And because we are rendering all of the 2D triangles at the same time, we have to have a texture atlas. I did want to put a picture up. I didn't have time to find one, but a texture atlas is literally a very large image with all of the textures from all of the things you see on the scene in one image. And if I go back, if you'll let me, there's one single paint that you supply for all of your triangles. That paint has a shader attached to it, which is an image shader. That's how it knows where to use these texture coordinates from. There's all going to be, again, those examples both use this, and my code will be pushed up soon, so you can all see how that works. And finally, as I said, we pass those colors across with the draw call, so we only get 2D vertex lighting. We can pre-calculate some 3D colors, directions of colors from normals, and they can be passed in those 2D coordinates. So we do get some lighting, but it's not like per pixel awesome lighting. You get gradients over triangles, basically. Gouraud shading is the name for it. Reverse engineering wipeout. So it's nice to choose so I could go render, some boxes and I can prove that the 3D engine works. Not exactly exciting, and also not fun when you're programming, especially when this is a hobby. So I chose to use Wipeout as my target. And one of the problems with using any current game out there, there's no legalities in reverse engineering as long as you don't ship the original materials, right? So you cannot ship the original Wipeout graphics because that is copyrighted by the original company. However, we can go looking to see how we can port something, and we can go browsing, and that's all perfectly legitimate. So these are we'll get to some of these individually. It sounds weird, but when you're reverse engineering, you need to think about it from the developer's perspective. So first thing to do, browse the original media, whatever content you've got. It could be an installed app if you want to go look at what someone else did. See what they've done, see how it can help you. Use a hex editor. You may not understand what a hex editor is and how it works, but just seeing it, you'll start to learn and you'll start to pick that up. And as I spoke about at the beginning about the original PlayStation hardware, that is vital knowledge in understanding how the game is put together. So learning about the original hardware and the original developer's intentions can be really helpful as well, whatever research you can find. And finally, why start from blank when you might be able to find someone else that's done some work already? So browse the original media. Really? Did it just disconnect?
Yeah. Internet.
The cloud is crap. I will tell you in a minute. Yeah.
See your saving. So every time you put a saving, you see like a 3D. Okay, let me just reshare that. Oh, they could, yeah. Let's see. Place those. Yeah, no, that's true. And just
We're back. We're back. We'll get there in a second. Hopefully.
I missed through this.
Please, like that. I must be the only one that has such problems. Right, browse the original media. I know you can't see this online, but it's just fun to see that the original dates of 1995 on the original files, which you don't see very often nowadays. And the file sizes are tiny. I mean, we consider like megabytes pretty small nowadays. Yeah, we're talking about a few kilobytes. So yeah, browsing through these original files, we'll find some of this track.inf file. An INF file on Windows is a setup file. It's not that. It's a text file, funny enough, and that's just open up with the text editor. That's what you see. This is debug information left on the original CD by the original developers. Thanks very much, guys. So it's giving us some interesting information here. Total vertex count. This is for the track. This is from the second track directory. Polygon count, size of a face, size of a section. These are handy bits of information to learn about. What can we find in all this information? So this is what we care about right now. The track info. We have a TRF file, TRS, and TRV. Okay, so from simple logic here. TRS, how is S different from the rest? Well, section. That sounds like a good plan, since the original has S. And if we take the number of bytes, divide it by the number of bytes per section, that tells us there's 319 sections. Some simple stuff. You could then read those 319, the 156 bytes for each section and determine what is different from one section to another, thus reverse engineering. Another example here, TRV, V for vertex. And if we take that original information that told us there's 710 vertices, divide that by the file size, and it tells us there's 16 bytes per vertex. That's kind of interesting because we can go look at each individual 16 bytes and see how they differ from each other, learn how to load them. And again, for face, we take that face size of 20 bytes, that tells us there's 1,378 records, which, funny enough, is the exact polygon count that they told us in the text file. So it all makes sense. And this is the key, really, just to go through and see how it makes sense. And again, the scene file, they're giving us all this lovely, apparently this came from Laura's computer. Thanks, Laura. And it was track final 2.4, because they went through that many revisions, apparently. So there's all sorts of fun information we can get. I won't go bore you with too many details, but that is probably a bit small. This is hexes that I use on Windows called Hex Workshop. It has this lovely data visualizer. What the data visualizer here is doing is it just draws one square for each byte on the right-hand side and colors it based on a grouping map. So green is actually, could be ASCII and so on and so forth. I won't go into it. But on the right-hand side here, you'll notice that we can already see that there's patterns evolving here. And this is aligned at 20 bytes. So it's hex 13 across the top there, including the 0 is 20 bytes. And there's actually column of data here. And what we've actually got here is the first indices, second indices, third and fourth for a quad, followed by it was the color and a couple of flags. I can bring up the data model. I can bring up the dark code in a minute if anyone's interested. So yeah, you can just read the bytes from a file. I mean, it's not too difficult. However, there are some files that you have no clue about. So opening up, there was a CMP file in the directory, open that up and it looks like garbled mess. If you see a lot of zeros or Fs or a lot of any sort of hex character in a row in a file, it means it's uncompressed, pretty much. So compressed data is high entropy, means very random. So when I open up the CMP file, I can show you what I'm talking about in a minute if anyone's interested. It looks very random. That normally means it's compressed. So after some searching online, I found this wiki page. This wiki page doesn't exist anymore and only exists in Web Archive. Thank you very much. And even better, they have I've cut it off here, but they actually have a C extraction snippet on how to decompress the file. So someone did all the hard work I didn't have to do. So putting these things together, slide. Actually, this chap here, after I do that fun stuff I just showed you, with some of our own research, I found this chap, Dominic, who did reverse engineering Wipeout on the PlayStation, and also came to the same conclusions I did, and actually had some more information that I didn't have to come up with from scratch. So I'm going to show you a few things, if the laptop allows me to. So first of all, they're not running super fast at the moment. Yeah. Well. So this is what we just looked at, the hex editor. I'm going to just show you what I was talking about the CMP file quickly, just to show you the difference. So you see there was a pattern on the left. Hopefully when it loads up. And this is the new file. That is compressed data. This is the little visualization for you. So let's get to something interesting, shall we? So I'll show you this. This is the actual 3D engine working. So this is very smooth on my side. Please, you can try it after in the break if you like. But yeah, this is actually rendering 3D polygons in essentially 2D triangles. If you look at his shoulder there, you'll see where it clips through. If I get the right angle, there you go. So one triangle is put in front of the other one, which the Z buffer would fix that. But for most games, even the original, again, all the original PlayStation games had this problem. Less noticeable when you're on 320 by 240 or whatever the original resolution was. But yeah, no, we have some 3D polygons being rendered, so that's interesting. There is going to be some improvements coming up. There's no clipping in this near plane or file plane clipping. That's still to do on the to-do list. After processing the original data, I can. How am I doing on time?
Maybe 5 minutes.
Oh, okay. Yeah, okay, we can do that. We can do that. I will continue and more than happy to show people this during one of the breaks.
There's a break, so no.
Yeah, we'll have we can lead into some questions and then we'll have a coffee break anyway. So I just want to show you these. These are actually the original code that I've written to extract the data outputs object files. These are sort of a standard graphics format. So this is all this 3D model that you see in front of you actually comes from Dart. So all these graphics and the actual model itself always is loaded out from some Dart code. And I load out the 2D sprites as just two-dimensional planes at the moment. And again, we have some really interesting. This is the vertex colors in action. So it looks like it's changing color with lighting, but what they've actually cleverly done is lit different vertices with different colors, and it looks quite cool. This is from the original game. This is all from the original game data. And again, the original ship models, all that kind of fun stuff, all come from the original. I will actually show you here. In this, you can see Z fighting happening here on the wing. This is because the underside and the top side share the same coordinates. So by culling out the back planes, we don't get that problem because the ones facing away aren't being painted through. Let's see. I also want to so I'll show you this. This is going to look rubbish probably. We'll try it anyway. So that is actually the guy who did the reverse engineering wiki post. Blog article. Wrote this. He's definitely not like scaling. We just. I can see this. No. Well, anyway, what's kind of interesting about this is that's all done with WebGL and JavaScript. So there's no reason why that can't be done with Dart as well. So if you have anything that you want to render in 3D, you can definitely do that using Dart directly with WebGL, which is where we're going next. If I can get there. So what is the future? I want to get some code. I don't think we've got time. Get some slides. Right. Future of 3D in Flutter. So currently, one of the reasons we're talking about those vertex shaders and fragment shaders is that shaders are a very important part of 3D. They've just added this fragment program. You can go use this right now if you want to, if you dare. What it does is it takes SPIR-V, which is a bytecode for shaders. There's a link. There's a link somewhere on. I think it might be current specification there. There's a link in the documentation that talks about. Can you take my face down for a second? The link there. There's a link in the original documentation which talks about actually processing your GLSL, that's the scripting language for OpenGL, or Skier shader language, the one that Skier uses, into SPIR-V, and then you ship the SPIR-V asset, it's a binary file, in your assets for your Flutter app. And then you can use these fragment shaders. Now, not gonna lie, that in their current state, it's still very early. So you can take an input from images. So let's say you wanted to do a waving flag or some other fancy thing like that. You can do that in this at the moment. It does have limitations, and they're working on it right now. So there's actually a link from that current specification to the project on GitHub in the Flutter repo, where you can monitor their progress. Wolfing from the Flame team actually wrote this really nice shader example. And I'll share the slides so people can get these links. However, this link, if you want to grab a QR code right now, this is a Dartpad example of Dart and WebGL, which you can currently use. The link takes you to the dartpad.dev, so you can try it out on your phone. You will see an error at the moment on the screen saying that WebGL is not supported. However, it compiles and works. This is a bug in Dartpad, and the team know about it. They're fixing it at the moment. If you want to get the source code, it's on the gist, which is the same hash. So it should be easy to find. In fact, I don't know if there's a good reason to show you maybe now. That is Dart code, rendering WebGL with shaders in WebGL. So the shader source code is over here, and all the coordinates, it's all there. It's a simple example, 160 lines, nice little rotating cube. I think that is it. Happy to open up to questions. And I think we have a coffee break. Since you've already had a bit of coffee, I'm happy to stick around and answer any Flutter question, as well as questions about this. The engine is called, the 3D engine I'm working on is called Zombie, named from the original Resident Evil work I was doing, and that is going to be published on pub.dev sometime over this weekend when I can find time. Yeah.
Question. So, wait, are you saying that can you run this game in a Flutter project as well?
You will. Is the point? I'm still working on it, right? So you can currently render 3D objects. However, I'm building the game out. Okay. So what we're not doing at the moment is going into the binary file, the original PlayStation game that's been compiled, working out the game logic and reverse engineering that. All I've done here is I've taken the logic to load their assets, and then we're just recreating the game in Dart code. So the eventual aim is to have it as an example of the engine running. There's thoughts about integrating the 3D rendering in other projects as well. So keep your ears alert for what might come. Anyway, I can't talk about it. Yes.
How does it run on a 4K screen? Is it still smooth? Or?
It's still smooth, yeah. I can literally zip up this example and send it over to anyone, and they can just run it if they want to. It's not the number of pixels. See, again, because the 2D verses are being rendered in hardware, the resolution really doesn't matter. Like if your GPU can handle 4K graphics anyway, it can handle this, right? The difference is the amount of 3D triangles you're trying to push through per second. So the original PlayStation, if you were very, very, very lucky, you could do 260,000 triangles a second. That's not many per frame. If divided by 60, it doesn't end up being a very, very many per frame. So we actually have this added advantage that we can probably get more performance. And again, once this is finished and we can get the game working, then we can benchmark and look at optimizing the path of using multiple buffers for the vertices. So we're reusing data buffers, so we're not regenerating and recausing GC and so on. But again, all comes in time, and we can't go there first until we have something to work with. I'm the type of developer I like to see what I'm building, and one of the reasons why I like using Flutter. So I could easily sort of work at this from the data perspective and have a bunch of tests that work with single or sets of triangles and expect to have a certain output. No, there's no fun in that. I want to see what I'm doing. Any other questions? Sure.
One. Yeah. Thanks. So is it that the single code base, so that let's say you make some 3D game and you can run it on both mobile and web and desktop already?
Yep. So because we're going around the pure Dart and Flutter route, and we're taking advantage of draw vertices, which is available on all those platforms, I say of all those platforms, you have to be using Canvas Kit on web. You cannot use it on the HTML renderer. So when I last checked, it wasn't supported. There's a very few Canvas operations that aren't supported on the HTML renderer. I'm not sure where the support is on that, but with Canvas Kit, it goes straight through to Skier.
Just now you mentioned that Flutter avoids that 30 megabyte overhead from like Skier. How does that work?
I just mean that it only compiles what it needs. So if you had all of Skier's support, Skier shader language, all these other things, it starts adding up more compiled code that you have to ship. Now, I don't know if that original diagram that I was showing in the last talk, which is the green section, which is the Dart side of things, that is tree shaking. It means it will only compile out of all the framework, all that Dart code that your app can use. It only compiles and includes what it uses. However, the engine ships as a blob of binary data. It's compiled code. So everything gets shipped inside that. So for them, keeping that size down is quite critical, because every app is going to take it on board. I would like to see, so the way Flutter is actually, the Flutter tooling, the Flutter command line, for example, is engineered. You can actually specify different Flutter engines to run. So having compiled the Flutter engine myself, you can compile it and tell it to use your version of the Flutter engine. I don't see any reason why the team couldn't, and this is just me talking, I don't know the team, what their intentions are, but there should be no reason why they couldn't have different branches or different forks. So a 3D version of the engine that has all this 3D support. And then the idea would be that when you compile your Flutter app, you specify, I want to use the 3D version of the engine, and you're happy to take on board that it's going to put an extra 4 meg on your app, right? I mean, most games are stupidly big, but definitely still smaller than what Flutter could offer. Yeah. Any other questions? Any Flutter question at all? Go for it.
So, what happens when there's no GPU on the machine? Like, does Flutter still run quite well, or does...
I don't think Flutter actually supports software rendering anymore. It's been a long time since I looked at it. So Skier supports software rendering. That's literally where it runs that rasterization, the fragment shaders in your CPU. However, it is very slow. I mean, I'd give anyone an interesting task of trying to go and download an old game called Quake, or Quake 3 Arena, I think it was. But Quake offered software rendering alongside hardware accelerated rendering. You can switch them in the options for the game, and you'll just see the performance difference. Even on a modern computer, it's still miles different. I don't even know what my point was.
So if you think about Flutter on the web, if I wanted to make like a web app for people with really low quality phones, then I would probably still want to go with like JavaScript stuff, like React stuff, and avoid rendering everything using Canvas Kit?
No. So there's an optimal path. So Canvas Kit is about the browser exposing skier. So there's actually a really optimal path there for use. Even HTML and CSS adds layers on top of what the rendering stack is. So there is no real difference in terms of Flutter rendering with Canvas Kit versus HTML and CSS rendering with Canvas Kit in terms of performance. The difference is for 3D, well, then you're doing what I'm doing right now is rendering all this on the CPU, doing a lot of the geometry transformation on the GPU, and then shipping 2D triangles for hardware acceleration to the GPU. Whereas if you use WebGL, it's all 3D accelerated, it's all being pushed over to the graphics card. So that's the advantage of some of those different options that we spoke about earlier. Yeah, for example, in here, you're taking advantage of hardware acceleration in the last step only for 2D triangles, and we're taking on the CPU. When it comes to Flutter WebGL is probably your best bet. You can still render the 2D triangles, but obviously the CPU is going to be doing more. And finally, on mobile apps, again, all of this still works on mobile apps. And I don't know I haven't got any performance benchmarks for you whatsoever. It works though, and it works pretty well for me. However, again, if you really want to take advantage of like all the modern, again, you're not going to get per pixel lighting with the current setup. So if you want to take advantage of all those things and fog and fragment shaders and all this fun stuff, then yeah, OpenGL and Unity are your best bet. But again, it's about what I'm doing actually puts 3D into the widget tree. So you can actually have a widget of 3D things, and you can scale it, fade it out, and it's all part of the same rendering side, where the OpenGL side of things and Unity is almost like a sort of a punch through of 3D in your environment. So slightly different approach, and there's different overheads in both things. Yeah. Any other questions? Cool. Well, thank you very much.
Okay, everyone. I think we're all here and next talk to Nellie Pereira with deep dive into daytime in Flutter. I got the echo. Yeah. Is it done? Okay, good. So I'm gonna share your slide. Hook you up on the. Is it okay?
Yeah. But it's in. Oh wow. Like one of those fancy buildings, and stuff. Like okay.
Okay, all you, Nellie.
Thank you. Hi, good afternoon. My name is Nellie, and I'm a Flutter freelance developer. And this is my first talk, public speaking, so please bear with me. The topic today is deep dive into Flutter, and deep dive into data and time in Flutter. So, date is a very important component, and I don't think there's any app which doesn't deal with dates and times. There will be something or the other, at least at the time I have worked now for about a couple years. I have worked with date and time. So there are a few rules sort of I keep in mind while diving into date and time, because at some point of time we need to collect, store, retrieve, and display date. So the few rules is you see that I see that the dates are in a readable format, and the format is consistent throughout the app. Date and time to be stored separately, and to choose the right package for your widget from the library. And before storing the date, I see that it is validated, so that we don't have problems in the future. So how do we get date and time? From the system, datetime.now gives you the current date and time. So this is the output. Okay. So you get the year and the hours, and we can retrieve each date element separately. Like if you want the year, you can retrieve it separately. You want the month, time, everything could be separately, or you can pick a format. I'll show you in the later slides. Similarly, time of day .now gives you time of day in hour and minute format. And as mentioned earlier, retrieving part of the date or time could be done separately. Like datetime.now.year would give you the year, .month would give the month, .day would give you the day, hour and minute, and so on. And similarly, the same with our time of day. You can pick the hour and the minute. Apart from this, you can get a DDMMYY, or there's various formats supported by Flutter. Converting date and time. Why do we need to convert date and time or time of day? Some APIs do not have date and time formats. They're stored as string. And when you want to perform any manipulation on date and time or time of day, you can't perform them on string type of data. So to convert, you can convert from string to date and time, time to string. These are the various conversion possible. Time of day to string, string to time of day, and date time to time of day. So we'll see how we can do that. In here, in the first line of code, this is a string date type stored in the user data variable. We use parse to take that as a parameter and use date format. This format could be picked any format you want. And there is a set different formats that's allowed. This is a language that you need it for. And with this, you can just convert it to date time. So this is the output down here.
Can you hide the thing?
Oh, okay. Yeah. So these are the various formats that are supported. D will give you just a day. Weekday is 4 E's here. And so there's various. There's YMD that will give you the year, month, day in number format. These are just a few, but there's more than this. Converting date time to string. So here we have datetime.now in a variable underscore datetime. We pass this as a parameter to format, and we use the date format, and we specify what format we want it to. And it's saved in stored in this variable here. And yes, we have our date time converted to string. So if you see this example here, there's various formats which I mentioned earlier, which can be converted and used. Converting string to time of day is a bit tricky. You can't do that, but we can convert string to date time, and we can convert date to time of day. So this example here is by using parse. So this is a small function wherein I'm taking the time as parameters and converting it into time of day by using the time of day dot from time of date, from date time method. Then converting time of day to string is again a bit straightforward. You just use the format time of day and it will just convert it to the format which you have defined. Here it's HMS. So what are the methods supported by time of day? So we have various manipulations, our comparison methods that are supported by time of day that can be performed on the data we have. So add and subtract. Add takes duration as a parameter, and duration supports all these properties: days, hours, minutes, seconds, milliseconds, and microseconds, and it returns a time of day. A typical example for this would be, say we have a 30-day subscription of Amazon Prime. So wherein you give the duration of days as 30 and you have your expiry date. And so similarly can be done with subtraction, but maybe in a different scenario. Difference. This takes date of time as a parameter and retains the duration. And again, duration means you can display the data in days, hours, minutes, seconds, microseconds, and milliseconds. So a typical example here is when we put a post on social media, it will tell you how many minutes it was posted. So 1 minute, 2 days, 3 days. Comparison methods is after, is before, and is at the same time. So they all take date of time as parameters and return a Boolean. So it's whether true or false, basically. And depending on what condition it satisfies, it will perform the actions. Like a typical example here is a tube ticket or a train ticket. You have different fares for off-peak charges or on or peak time charges. So if it crosses a certain time threshold, it will charge you differently depending on which condition it satisfies. Compared to, it takes date time again and it returns integer. So compared to, if the date is in the future, it will return you a negative. If it's in the past, it will return you 1. And if it's in the future, if it's same, it will just return a 0. So this is similar to difference, but it just returns you integer. Sorry, similar to the comparison methods, but returns an integer. The other methods supported are toLocal, wherein it converts the UTC time to local time, and the UTC, and the next one is UTC. It converts local time to UTC, and toString is basically to convert toString while you're displaying the text. Date and time pickers. Date and time pickers are basically sort of widgets that allow the user to enter a date and time. Calendar, maybe you can have different ones. And why do we need them is we need the user input. What are the different types of date and time pickers? So we have single date and time pickers. We have a range date and time pickers. And we have multiple date and time pickers. And most important with these are whenever dates and times are selected by the users, the best is to have them validated and see that there's some validation once the selection is made. So I've just picked this Flutter date time picker from, it's a Flutter package, and I've just taken this as an example. So this one allows you to pick a date, time.
You just got connecting into the Wi-Fi and share the screen. Just trying to think it's connected later right about the page. Let's go ahead and share the screen.
I'm using the Frontends. Yeah, that's true.
Can you try to share it?
Yeah, I've shared it.
Go to the stream. Go share. Share screen. Okay, now you can go to slides.
What is it showing? Okay. So, sorry, coming back to Flutter date time picker. Well, this in this widget, sorry, you have you can pick date separately, time separately, and date and time together. And it supports multiple languages, and also you can customize your content in the picker. You can change the themes, the colors, the way how it looks. So the first option here is show date time picker. So this will allow you to pick a single date. I don't know if that's readable.
Can you try to present? Can you try presenting?
It comes up with that big, I don't know why this is showing up.
You can
Okay. That's fine now. Sorry. Okay, let's go back. One slide. So, okay, let me just explain this. So, show date picker will just show you just the date, and time will just allow you to pick just the time. Date and time pickers, you can do both. This is as well as okay. The show picker can be used to customize, and show time 12-hour picker is sort of self-explanatory. It just gives you a 12-hour format. So this is a show date picker sort of small example wherein it will, when you call this function, select date, it will open up the screen and it will let the user pick a date. It has got a few required properties, which are context is context. Initial date is the date that you want to see when it first opens. First date will be the starting date or the time where you can allow the user to pick a date, and end date would be the last. So it's basically the window between when the user can pick the date. So in this case, it's from the year 2020 to the year 2050. And over here, I have a validation. So I'm just checking for the data, if it's not null, if it's date time. Date time is basically current date. That means when the widget was loaded, the user didn't select the time. And then I save it as in the date time variable. Similarly, for show time picker, it will display this option for selecting the time, and it takes two required parameters, that is context and initial time. So these are the times that will display when you open, and it takes a time of day for time. Show date and time picker, again here, it will allow the user, if you see, to pick the date as well as the time. And over here you have the min time and the max time. This could easily vary. Or, sorry. So on changed, you need to specify what needs to be done when it is changed, and on confirm, you just need to give the action and what is the current time. The second package here which I've used is for time range picker, wherein with date time picker you can just pick a single date and time, but with time range you can pick a slot. This is especially when you want to book some appointment sort of app thing, so where you can restrict or you want to lessen your code, or have some additional functionalities like this one. Again here, it gives you, lets you pick the duration, intervals. So like in this case, I've set 30 minutes. It could you could change it to hours or seconds as well. And there's different styles which you can use to display. So I have used here stroke, but there's many, you just have to explore. It also has disable time, wherein it will block the time that you don't want the user to use. So over here, I have blocked from 1800 to 9 o'clock. So this is the open time slot wherein I can change or alter or pick a slot, and each individual slot is at an interval of 30 minutes. Sorry, this has come. The third package is Sync Fusion Date Picker. Now this is something very new, and this supports all. This supports all three. So you can pick a single date, you can have a multiple dates, and you can have a range of dates. Where in the previous two, they were just limited to either single date or either range. So this one, plus there's many other options like blackout, so you can just cross off the dates, and disable dates to restrict selections. Well, I haven't seen those sort of properties in the previous two. So over here, like for a single date, you have a single month, a day, month, year, month. I think this is a bit too small. I'm not too sure. Let me see it, but yeah. And for range, you can have choose a single date range, month range, year range, and a decade. With multiple dates, you can have multiple dates, like just one date or many different single dates, a range and a date, and two ranges. Since datetime class does not provide internationalization, Intel package is very useful, and it does support a lot of date formatting apart from what we already have. Its popularity is 100%, and it absolutely works wonders when you really want to play around with your date and time. The other packages I spoke about was Date Time Picker, Flutter Date Time Picker, which is 99% popular, and so is Sync Fusion Date Time Picker. This is a fairly new account. I don't remember how new, but it will be picking up soon. So yeah, thank you. Any questions?
Earlier in the talk, you said like always use daytime and time of day. What's the benefit you found from like separating the two instead of just using time straight from daytime?
Using what time?
Just like only using daytime and not using time of day.
Well, I said separate the date. When you work with daytime, you get the date as well as the time. So when you're storing them, I said you have to store them separately in your API or database, because when you're retrieving them to perform any function or to perform any calculation or addition, it's easier when you convert it, because you have to convert it in an API which doesn't support date time.
Okay, yeah.
Yeah, because there are there are databases that support date time type, but there are some which doesn't support. And when it comes to that, it does help when you separate them out.
Thank you.
Okay, I have a small question to the audience for this bottle. In the slides, she had a code that had a year date range between 2020 and another year.
50
What?
2050.
2050, he said it first. Yeah, that's right.
Thanks.
Okay. All good. Thank you.
Thank you.
Thank you.
realized. Okay, I just want my data. Here's my data. Give me 50 people.
Started sharing yet?
Share again.
I think I have that on the. Oh yeah, I've got it. Can you choose this now? That's too late. Yeah, please don't come back. I don't know. Really ashamed it took me so long.
Okay, so hi everyone. Thank you so much for attending my talk. I know it's a little bit late, so thank you so much for making it and attending my talk. Today's talk is about three topics: gestures, animations, and scrollables. And I know that the first question that you have in mind is absolutely why are we talking about three topics in one talk, and the second is why these three topics in specific. So the first question, like the reason or my main goal for this talk is to encourage you to do something, which is to discover again. And what do I mean by that? This is coming from an experience like that I have had multiple times. It's like an issue that I have had multiple times, and I know that other friends, people that I know have had this issue before, which comes like this. So every time I see a new framework in the context, in our context, this is a Flutter, I see a new framework, a new tool, library, or whatever, I get excited about it, watch a couple of talks, and then I decide that I'm gonna go into it. Like for the next 3 to 4, 5, 6 months, I'm fully into learning mode where I try to learn everything about the language and do exciting stuff. It's like a really fun, like we can call it like a honeymoon with that language, but then we have to realize that we need to use it for something useful. That can be our job, a client, or even for a side project. At that moment, when we commit to doing something like this, it means the end, and we will start doing like daily tasks that are using the knowledge that we have earned in the first few months. And from that moment, the learning isn't gonna stop for real. It's just like it's gonna slow. We're not gonna be learning this as much as we used to in the beginning. That's probably is good because it's building experience. Right now we are goal oriented, where we are looking for solution to real world problem that we are facing. But when you look at the statistics that I don't have, but it is like what I have seen and what I have seen with other people, like all of us go into the learning mode and then use the tool for the job and then learn on a like slow pace for the next couple of years. When we never give, like I've noticed, like we never give the chance to rediscover the framework or the tool again. And I tried it for multiple times, and every time I try to look like at an API, which I'm sure I know everything about. I look at it the second time, like after using it and working with it for a couple of years, it gives me a fresh perspective. It feels like I'm learning something totally new about the same things that I have read multiple times. So that's my goal for today. I would like to encourage you to go and read about the stuff that you think you know and rediscover. So we are going to talk, I'm just going to do you a favor and talk about 3 different APIs that are available in Flutter, and we look at them from a different perspective. That means we're not going to look at them the way we are supposed to go through them. Like we will see in the next few sections how that goes. But before I do that, let me just put my phone here so that I don't go with time, because I have a lot of slides and they have just a little bit of time. So I'm going to go a little bit fast. If you have any question, please just note them, and we will have like the last 5 minutes where we'll try to answer them. So let's take a look. This is a very simple video, just like 6 seconds, where I have an interaction with the screen. I like have a touch with the screen. I let go of my finger, and then the list keeps scrolling. This is very basic stuff. Like you can imagine that this can be done with a list view. view. But what goes underneath that is multiple things. So the first is when I have an interaction with screen, the moment I have an interaction with the screen and start moving it. The second one is what we notice, the visible elements are updated, new elements are showing up, other elements are being removed from the screen. After that, when I let go of my finger, if I scrolled so fast, the elements are going to keep moving. If I scroll to the edge, some kind of an animation is going to happen. So that's why I'm trying to, where I showed you the video, these steps or elements here are exactly mapping to the topics of today: gestures, scrollables, and animation. So don't worry, I did not pick these topics just using a random generator to have some kind of thought. They are somehow related, but not in the big picture. So let's start with the gestures as our main for today. And the perspective that the way I'm going to tell the story of the gestures here is we will take a look at the journey of a pointer event and what do we mean by that at the beginning. So when we have an interaction with screen, we all know that Flutter is composed of two important parts. The first one is being the engine, and the second part is being the Dart and the Flutter framework. So if we would like to know anything happening in the hardware coming into the Flutter side, that's how that we can use it. It's going to happen in the engine. So this is where it's happening. I'm putting the code here. Well, there is no reason for you to read the code, but this is here in the engine side of it. As you can see, Windows C, C++. This is on the Flutter engine. It's sending the data, but what we need to look at is line 35 to 36. This is where it gets interesting because it is sending some kind of data to Dart, and that's how the Flutter or the Dart side connects with the VM side in the engine. So here we are just making dispatch pointer data. The Flutter framework is doing a dispatch pointer data packet and annotating it with Pragma. This is a way of telling it that this is going to come. This function is going to be invoked from the engine, which is written in C++ code. So from that moment, we get to all of these details. No need to worry about any of this, but just focus on what's happening here. It's getting the data from the engine as a raw data, and then it will try to send it to the Flutter side in a data structure called pointer data. This pointer data is now going to be available in UI window, and this is something that we can actually use. So what I'm going to try to do in the next few slides is let's try to build something that we can click on without using any of the without any of the APIs that are provided or any of the widgets. So how can we do that? I'll start with making a very simple example, raw data example as a stateful widget, and then I'm having in its state on pointer data packet, I have this callback where this is going to be just showing me, or this is just going to be reporting every event that's coming from the engine to the Flutter side. So every type of pointer data that the engine is sending is going to be here. So from this moment, I would like to tap on the screen and see what happens. So a couple of events, hover, down, up. There is so much more details that the Flutter engine is sending, but this is what I would like you to focus on, is the pointer change. It starts with a hover. I was testing this on a desktop device, so there is a hover, which is like just when you have your finger as or where you have the mouse on top of an element. So this is hover, and then there is down is when you have the tap or the click. You let go of the finger and it's up. All of them here are recognized by touch. It can be by a stylus, it can be by an inverted stylus, or even by a mouse. And then we have the two positions, which are the coordinates of where the pointer data happened, the X and Y, and then the timestamp. So from this very small set of data, we can build any type of gestures. So how do we detect a container is being tapped here? So this is a little bit retarded, because why do we need to do any of this if there are like tools to do it? This is just to decode the framework and then insert how to use it. So I have a red container here, and the way we know the position of an element, I just don't want to like use a hard-coded value. I'm going to use a global key in order to access the element for this red container, and then I have a list of callable callbacks, sorry. these callbacks are going to be mapped into a rectangle. So each rectangle, when we hit that, when we hit or intersect with that rectangle, it will try to invoke the callback. This is just the container that we have in the center of the screen. Now in init state, I'm going to do something. Don't worry about the details, but just focus that I'm doing this on at post frame callback. What does that mean is when Flutter has built the widget, that's when we know its position, because we don't know the position of a widget for when it's built. So that's why I'm doing widgets binding instance at post frame callback. This is just a boilerplate of saying once the widget is built, that's when I will be able to access its size and position. Sorry. So now I have the size and position. Let's use them for something useful. Yeah, probably you can see a little bit of this code, but all I'm doing is that when the widget is inserted into the tree, I'm going to add its position and its height as a rectangle, and I add a callback which should be triggered as it will just do print container type. And now we are doing this in handle pointer data packet. This is the function that, as I said, will be invoked every time the user has an interaction with the screen. That can be just a hover or can be a click. So we are getting the raw data. Let's filter them a little bit and just get the down events and see if the pointer event actually intersect with any of our rectangles. So if it hits one of them, then call the callable function that's doing this. Oh, that was a lot. I know, like there was so much going on, and we really did not need to do any of that because Flutter is doing all of that. So imagine doing all of this like the same what he did for a tab or a long press, a pan or a swipe, or even with we exploded to other things like secondary tab or scroll or rotate. That's like a lot. So obviously Flutter is doing all of that for us. If everything we want to do is going to be probably doable with just a gesture detector. But what's the difference is that now we understand how it works. This is the process of how Flutter is able to detect that the widget is clickable, or that widget can be we can click on it or not. So it starts from the Flutter engine where we are receiving the data with platform dispatcher, and then we convert it into something meaningful in the dark side. And something meaningful is class called pointer event, and then the process of hit testing. Probably you have heard of this word, hit testing, all over the place. What does it mean? Is actually just knowing which items that are hit testable, or the items that we can do some kind of a pointer event on them. I'm going to use the word tab because it's the most common gesture. So we know the widgets that are hit testable or clickable in this case. So that's what we did in the example. We know how it works. Flutter is doing it in a more optimized way, but it's all. If you have ever written a render object before, you know that there is an optional, or sometimes it's not optional, where you have to tell them if this widget is head testable or not, and if the head testing areas should be bigger than what it is. So, for example, let's say you have just a button, and the button is too small, and you would like the user to click on it, but they shouldn't really click only on the area of the button. You would like the area of the clicking to be a little bigger. That's when you do change the rectangle that is head testable, and we can consume that from all the gesture detection widgets like gesture detector and or anything. Talking about widgets, these are some of the widgets that use in gestures. Gesture detector is the most basic one. If it provides us with all the common gestures. If you would like something custom, we use raw gesture detector. Quickly, I'm gonna go through ignore pointer and absorb pointer because they are like utility widgets. If you have like a button or like you have a tree of widgets and you would like to disable the possibility of clicking on them or even being targeted by any kind of pointer events, you just use ignore pointer or observer pointer. What's the difference, you say? The difference is that ignore pointer is just going to do it for the current widget or the current area of the widget, while observer pointer is going to be doing it like on a level where we have like two overlapping widgets, and we have ignore pointer, like the widget in the back and the widget in the front. we click on the widget on the front and we cover it with an ignore pointer, that means the widget behind it is not going to be clickable. So that's what they are doing. Mouse region is recently introduced because now Flutter supports desktop, which means we need to know some events like the user hovering over something, leaving or entering that thing, which is probably mostly a widget. Listener is probably also the lowest level, where we get the same type of data that we are getting that we were getting from the raw listener in the previous example. So if you would like to listen to the same kind of data, you can use just the listener widget. And now I think we have so much time to go through all of these callbacks here. So if you're ready, just take a second. And yeah, I'm not going to talk about them. I'm just going to color them and then organize them a little bit in order to at least see that API is a little bit confusing. It's not Flutter. It's not like the Flutter way. Flutter is we are recognizing it as every widget is doing something. So there is a really like small number of features and properties that you need to provide. But if you go to something like gesture detector, the API is like scary because they provide so many of these. But when you look at them, it's like just repetition and same events with different kind of triggers. So for example, on tab is being tapped. If let's say a mouse is a simple example. On tab is when you click on the left hand of the mouse, and on secondary tab is on the right hand of the mouse. Tertiary tab is on the middle of the mouse, and it goes on like that. So they are just repetitions, and the API isn't as scary as it can be. But there might be some confusion. I have had this before where I wanted to understand like the difference between these events. So down is the first point of interaction. You let go of your finger, that's up, and then it doesn't become a tab until some duration. And if you take away your hand, it will become cancelled. So what are those durations? The durations are all, or if you would like to change them, I think it's gonna be a little bit hard to do them straight from the framework because they are in the constants of gestures, but this is the flow of them. So on top down is the first interaction. It happens at 0 millisecond. That's when you hit the screen, and it doesn't graduate or doesn't become on top until there is like 150 millisecond. If you let go of your finger before that, it will become on top console. And then we have on double tap. That's like you have the on top first needs to be triggered, but then there is a duration between this first and the second tap, which is defined by 40 to 300 millisecond, and the longest is on long press. That happens only after 500 millisecond. You let go of your finger, and that's a tap up. Now, before the drink, let's just talk about something funny, which is I'm not sure if you have noticed this in the Flutter API, where we have on tap and on press like so many times. What's the difference, and why would you use on tap or on press? Because we know that they do pretty much the same thing. So there is no official answer. I did not get this from documentation or anything. This is just my observation to it. Some widgets like gesture detector and well, they have no visual UI to them. They are just there. Like if you put a gesture detector with no leaf child, it doesn't have any UI. Same for an equal. But all of these buttons over here, floating action button, text button, cappuccino button, whatever it is, all of them have the same. All of them have like a visual component to them that the user can see. And you probably, just by looking at this example, you say like, if it is a button, it has the ending prefix of a button, it means it is on press. If it's not, it means on top. And it is proven wrong because there are other events like the drop-down button. So the API is a little bit confusing. This is not an official answer. This is just what I observed. Now, time for a drink, which is going to be Scrollables. And to do add GIF. Okay, let's see the next one. Oh, maybe not. Oh, too late. Yeah. You can imagine what these widgets are. I'm pretty sure most of you here have at least used list view or a page view or even a list view scroll view. So you can just imagine what are those. As I said, I'm going to take a different perspective on this. So I'm going to talk about the common part between all of these. So all of these widgets that I described in the previous slide are like this. Like we have a list of elements, and then we scroll in whatever direction. The elements are being disappearing or new elements are appearing. So how does that happen? Because the elements are hidden. So the widget is kind of like this, like the elements are there, but they are just not, they are just being clipped. So the widget is like this. How many of you actually recognize this? Okay, a lot of people. Then this is the TARDIS from Dr. Raouf. So what's very popular about it is like it's bigger on the inside, and you can expect that there is a widget for that in Flutter. And what will be the name of it? I was hoping that the name for it will be TARDIS, but they have a better creative name called the viewport widget. So viewport widget, I'm not showing you the documentation here. Hopefully you can go look it up, but it is basically a widget that is bigger on the inside. How does that work? This is a very simple example. I have a viewport widget, a couple of slivers, and this is what's being rendered here on the screen. And when you go to look at this, there is no scrolling. You use your keyboard. There is no movement. So this is very still. Like you can imagine, this is as a column, and this is what we are seeing. But the difference is, if you use a column, for rendering all of these items, you're gonna get a render overflow, right? This case it doesn't, because the widget is bigger on the inside, and it is able to handle all of this. And the reason we're seeing this view is because we have the viewport offset. So now let's play with it. Let's change it to 500. We're seeing a couple of other items, and other items are disappearing. So this is giving us a hint of what's happening. I think it is very clear that we can use this to make something useful. So how do we respond to user touch? Because this is about scrollables. So let's go back to gestures and use this widget that is called the listener, because as I said, this is where we get the low-level details and pointer data. And I forgot to tell you, but the difference between pointer events and gestures is that pointers are the raw data. They like you get a whole bunch of them, and then based on the position and the time between one and the other, they are composed into semantic things. They are called gestures. So that's the difference between them. But here we are listening to pointer events. This is what we are doing. We are looking for a pointer scroll event. If there is that, then we increase the position. You can expect that this position is what we are setting to the viewport. And then I'm going to have this very beautiful list. Like I have recreated the implementation of a list view, kind of, because my replica has strong breaks. If we go back to the previous GIF here, as you can see, like there are problems with what's being highlighted. Like it's clearly there as a problem. But what's more problematic is that this is like responding only to my user, to the touch event. So if I let go of my finger, it's not going to continue scrolling. It's not going to do any kind of animation. If I hit the top, as you can see, it doesn't stop compared to any other widget. So you can scroll until the end. If you are out of the view, the events are not getting there. So as I said, the replica has strong breaks, and this is just an explanation for you to remember how that works. Now, time for animations. What's that? It's this time for a snack. Do we have more time for it? Hopefully, yes. So animations in a list view. Animation in a list view from a different perspective is you have this example where we hit like the end of a list view, and this kind of animation happens. This is not being triggered by us. This is as a reaction. So this is where the animation is happening. It's not like an animation controller or anything. This is something else. So I'm going to ask you a question here, just for a little bit of engagement. How many of you think you can build? I'm not going to ask you how, so just don't worry. I need just a little bit of engagement in the room. So how many of you think that you can actually make this list? As you can see, this is an infinite list of elements. It doesn't stop at any point, and the elements are not like just increasing, like the number of elements is limited. So the question is, how can you do this without using animation controller or any other implicit widget? Like how many of you, like in 5 seconds, can think of a way where we can do this without using that?
You respond correctly, you win this.
Oh, now that's a really hard question. Okay, we have two people, but as I said, I'm only gonna say the answer until next. So
Okay.
yeah, so what's happening here is an infinite list with an unbounded animation and no animation controller and doesn't require any gesture input. How is this possible? Let's take a look, and this is just the scaffolding of it. We have a list view scrolling horizontally, and this is just drawing the element itself. So nothing complex there to see. But now here's the interesting part. We're creating a physics simulation or a scroll physics called infinite scroll physics. This is a custom one where we are not taking anything from the parent. So we are just applying ours to the scroll physics. But here is the interesting part, create holistic simulation. So now we have another class to look at, which is the infinite scroll simulation. So with the simulation, we are getting a value of time, and then we can set the velocity or the velocity, which is dx here, and the position, which is x here. And if we want this list to scroll by itself and never stops, this is where the simulation is done, is setting it to false. I'm setting it here to false, which means this animation is never gonna stop. So you can actually see how many interesting things we can build with this. So let's play with it. You can make a fast list where if you would like to build a list that scroll faster, double or 10x the normal scrolling speed. This is like the fastest way of doing it. If you would like to make an iPro4 feature in the next few days, you can just do this with a scroll physics, where the user, if they is scrolling from up to bottom, then this is going to scroll from bottom to up. This is like pretty much what they think of as the quickest and the smallest amount of code that we can use in order to implement that feature. And you can obviously see that we can implement other features. So I'm not encouraging you to do all these types of features, but this is just one of them where you're like, I'm gonna make like a banner with a portrait and use to report. And not sure how many of you read it, but if you read it, this is the summary. Hopefully I have shown you some interesting stuff about gestures, and we understood how the gestures are coming from the engine to the Flutter side, and some common handlers and the your timeline, and also what's the main factor or what's the main common thing about all the scrollable elements and how do they work. So that's the magic behind scroll views, and a different perspective on how to do animation that has nothing to do with animation controller or implicitly animated widgets. That's it. I hope you liked it. More time, but if you have questions, probably
we have questions. Yeah, I think we can
in a second or two for the
other three questions. Yeah, someone.
Okay. Yeah.
How did you learn to talk so quickly?
I don't know, because I was just scrubbing the words around. I'm not sure how much did I miss, but I just scrubbed the word around.
Nice scrolling.
Custom speech.
Okay, so we have one on YouTube. I think we can answer that. Someone's have a question about scroll controller. He thinks that for loop can also do the same, but maybe it'll be expensive.
It will be expensive because the scroll controller and the animations in general in Flutter, they have this neat feature of VSync, which is so it's like doing a for loop is pretty much the same as doing a timer, where you're like on a like every time, like every 1 second, every 2 seconds, or even if every 1 millisecond is gonna change the value. A change in value is an animation, so we can do it like that. But what VSync is doing in Flutter, and that's where we see it most of the time, is if you leave the view, the animation is gonna stop. So let's think of this as you have a main application, and the main application has a count, like a timer on it, and we can build that timer using two different methods. We can use it like with just a timer, where we are like increasing the value every 1-2 seconds, and the value is increasing and the widget is animating, or we can use it with a VSync. The difference is if you have another page, you click on it and you move on to the next page, the timer on the screen behind is still going to be going around. It's not going to be stopped, at least unless you do that automatically or unless you do that manually by hand. But if you use vsync, that's going to be free for you, and also the other part, which is it's going to be syncing with the internal clock of the system. So if the device is like limited to 60 frames per second, that's what it's going to be. That's what the rate of the frames is going to be, and the rate of updates is going to be compared to like another device. So yeah, using a for loop is going to be expensive, and it's going to be synchronous, and is not optimized. So use just an animation, a scroll controller, or an animation in general.
Okay. Guys, just one last question in the slides. The item list, it was max number. What number was it?
I don't remember.
20? 100?
No, it was not shown, but in the code, it wasn't the code.
10,000.
Huh? Can you show the code again?
I was so fast. Sorry, everyone. Sorry, I know I was so fast. That's why. Can you repeat? Which one is it?
So when you create the item list, back the list, that one. When you create it on the scroller, yeah, there was a for loop. And
oh man, I created so many. Okay. Yes. 100. Sorry, 100. Guys.
No, nobody.
Is it 100?
Yeah. Well, that's the disadvantage of talking so fast. I'm gonna miss so many things.
Some people catch up.
Yeah.
Sorry.
Is it in there?
Yes. No.
The one I have is super.
It's quite a lot of features. That's quite good.
Hello guys, can I get a bit of your attention please? Okay, last talk. I think it's already Nico.
This is Nico. Should be fine. Oh,
it sounds good.
Sounds good.
Okay, let me. Okay, it's the last talk about testing. Maybe it's kind of a boring talk for most of developers, but yeah, let's try to make it quick. And it's not about like how to test, but more about some cool ideas. Because like when you are trying to test a product,
It's more than just like trying units or trying integration or E2E, but it's about like putting all this together in the right way to make sure your product is doing as it should be. So I will try to share some ideas, and hopefully it will solve most of the common problems that you may encounter when you are dealing with the Flutter in some cases, and when you're working with a whole system with front-end, back-end in other cases. Let's title may be a little kind of confusing, so let's talk about the table of content. Here we will talk about we'll start with highlighting some software engineering concepts that are needed in order to maybe talk about integration in E2E later. But we will start with trying to find good ways to do unit tests, and also business logic. We need to try to find maybe when to test units with unit tests versus where you need to do business logic tests, and also we will end up doing widget and visual tests. And later on, I think for most cases, when you try to do integration and E2E tests, especially like with the front-end systems where you have also like back-end there, and also you have like third-party integration, is maybe a bit tricky in a lot of cases. So we'll try to provide some tools and some solutions around that. So a bit of my background and who I am. I'm Jamal. I do building software engineering for a few years now, and also I solve problems of existing products. I work for a company called Brand Ambassador. We promote it as like the ultimate ambassador marketing tool for brands. If it's about my background, I started early with Angular, Ionic, legacy stuff, and then I moved to React Native, and now I'm doing Dart and Flutter while supporting also legacy Ionic in some of my projects. You can find me everywhere at Djamaleddine Belilet. But moving to the more interesting stuff. Maybe you will end up with a solution or a product where you really don't need or don't want to have tests there. And even in those cases, I think these are essentials, even if you are not willing to do testing in your solution for a reason or another, but these are essentials. So for any of you who worked with Flutter before, I think you already tried either VS Code or Android Studio, maybe IntelliJ IDEA for some users. And for most of those, we have Flutter Analyze already there, which is just a linter if you are coming from like web development or backend development. And also we will try to talk about Dart code metrics, how we can bring them there. And I think one of the key concepts, if you are pushing forward to the production, is to have monitoring and error tracking solutions. We'll talk about all of these in a bit. Starting with static analysis testing. This is out of the box if you are in the development process. If you are using VS Code, IntelliJ, or Android Studio, you have Flutter Analyzer out of the box. It's what will show you this kind of errors in VS Code. I will show you in a bit underneath. Or if you are running on Android Studio, it will be the same thing. But if you are running on a CI, using a CLI, of course, or using a tool for CI/CD, it's really necessary to have also Flutter Analyze there, because you may miss, maybe you are merging a pull request, and there maybe will be some errors there that you didn't catch up with your IDE. So it's really essential to have it, and it's really easy because we have Flutter Analyze, which is one line of code that you can add to your CI/CD solution, and it will work out of the box. Now, when it comes to static analysis, there is another concept which is called Dart code metrics. The community did a really good job there. There is a package. You can just look for Dart code metrics, and you will find a package supported by the community. And there is just about some common patterns that your code needs to follow in order to maybe be more healthier, and maybe it will perform better in most cases. And what's really cool, if you are using an all-in-one solution like Codemagic, you will have it out of the box. I can show it in a bit. What this I'm picking this output from Codemagic outputs, and basically you will get if you have issues, you will get like them raised here, and like anti-pattern cases that will be raised here. But it's what is really like analyzing there is things like this, like the number of line codes for a specific file, or like the maximum nesting level for a specific, let's say, a widget tree or something like that. And also, this code concept is really common between almost all the software engineering languages that we have there, and it's about maintainability index. This is pretty low. It goes usually from 0 to 100, but it's still something that we can accept. Now, for monitoring and error tracking, it's more about like after that. So we start with static analysis. We make sure like that there is like no anti-pattern like problems with our code. The next step is maybe to move forward. We set in our CI/CD solution to also test that once again before like hitting the production phase. But once we hit the production phase, our users are our testers at the end. Whether you have like E2E, whether you have like integration, unit tests, at the end there will be users who will test your application, and unfortunately there will be bugs that they will encounter. Whether most, I think, there are good and bad users, but still they are all users of your solution. Some will report that issue to you, and that may help you, figure out that, create maybe feel an error issue, or the developers will solve that and it will ship again. But in most cases, users will not report. They will realize that bad review on Apple Store or on Google Store, and that's bad for your application and also for your business. For that, you have the solutions like this, like Firebase Crashlytics or Sentry.io. There are more, but these are like the ones I use. And moving forward, maybe there will be a lot of things that are like things I use. It's not maybe the best solution out there, but at least these are the ones that I tried. And let me just walk you through how to set like the Firebase option. It's pretty easy to add. Let me double check if this is visible. Can you read that? Yeah, so basically it's a package that you need to add, which is Flutter, Firebase Crashlytics. And then this is an optional step. You need to deal a bit with the native stuff. It's 1 or 2 lines of code that you need to do to add using like Gradle, and also I think for iOS you need also 1 or 2 lines that you need to do, and then you run it. Basically, you can go backward to this link and you will see this promotion and what it's saying. But basically, this is just about like tracking, have like the error like stack there, and also ways to maybe be able to reproduce the bug, and also help your team maybe solve that issue as soon as possible, and make sure that this bug is reproducible. And you are already, at least if you know that there is a bug, it's better than if the user knows it and you don't. This is really bad for you. So let me get backward. We have Sentry.io, pretty simple to use, and it's I don't know, there is a lot of functionalities there. There is tracking, and both like have a lot of visuals about like how your app is performing. Maybe there is a crash error, maybe there is some performance issues with some specific devices. All these can be reported, and it also can be tracked to specific contexts. Let's say it's a specific domain. If you are doing like domain-driven design, maybe a domain is the source of your problem. So you can maybe tag this kind of error like handling with this specific tag, and later on it would be more easy for you to track that error and try to solve it as I said. I talked about 2 other options, which is like the static analysis. I'm representing here like it's from Codemagic, but since we have that part as of the CI, which is Firebase Analyze, and also the code metrics coming from the community, it's something that you can integrate with more like with other options. But here with Codemagic, it's out of the box, and it's basically just a step of the default like workflows. You go to the test, expand it, and you have here like the static analysis, where you have like either enable Flutter Analyzer, which is Flutter Analyze, if you are using like the CLI tool, and Dart Matrix, which is that set of like good practices and patterns that you need to follow in order to fill this kind of requirements. Okay, let's move forward. We again, even if you are not doing tests, please make sure you at least like check this out. It's pretty easy to add them, but the benefits are huge. You like the static analysis is one line of like terminal code, and for the dart meter, it's pretty easy to add. Firebase, we saw it, 3 lines or 4 for the native configuration, and then you have it basically. Sentry is basically the same thing. Okay, moving forward to testing now. Okay. But just before that, we will talk about state management and domain-driven design, just like some hints, so we will be on the same page when we talk about more advanced specific things with unit tests and also visual and integration tests later. Okay, when it comes to state management, I will talk like as if I'm using Blog, but almost all the concepts here are based on, let's say, provider, which like Blog use under the hood for some things. So basically, I think most of the developers with Flutter are using either provider or Blog, and now are reports which feels like in the same family. So what I'm trying to say here, whatever solution you are using for state management will be valid here as soon as you follow the following patterns, okay? But when it comes to Blog, the way it works is we have like the data, and then it starts with the UI, and there will be like user events, okay? And we have like those blocks, which is like just a set of like a block of business logic that we will be using, and it will react to the UI through events, and it will return states, okay? And then this block may reach out to a data source that can be like a GraphQL backend, a REST API, a third-party solution, anything that can be like outside of your like business logic brick, okay? There is an like simplified version of this, which is qubits. Same thing, but it's like if you have qubits and Block, then you have the best of both worlds. If you have like the let's say the provider way and also like the event-based way. But anyways, doesn't matter what you are using as a state management, as long as like your business logic, your UI, and your data sources are separated in a way. Okay. Moving forward, let's talk about domain-driven design. I think there was like a talk about the micro framework, which I think if you follow it, will make this easier for me. But basically, domain-driven design is a huge concept. You can look it like later, it up later. But here it's more, if I simplify it and abstract it in a way, it's just about like making your sorry. I'm still connected.
Yeah, sometimes just.
Oh, okay, I need to try maybe to.
We tried to get him to.
I'm sorry for that.
We had a couple of. Try to retry. So.
Okay. Okay. Sorry for that. Sure.
Yeah, that one. Okay, I'll bring you up. Yeah, there you
go. Okay, I hope you see following. So yeah, about domain-driven design, if I abstract it in a way, it's just we have a product that have like domains. It's more about business domains. So let's say in an application, I have like accounts management, and I also have like brands management, and I have like posts management. So I can like, if I can encapsulate those into modules that will be responsible only about like that mission, that would be great. It will be easier for me maybe to maintain those later. Maybe there will be like teams that are like dedicated to work on specific domain, things like that, okay? But like it will help also like from like if we project what we have like in the whole system, backend, front end and stuff, we will end up with these kind of layers, okay? It's may not like be relevant in all cases, like for the front end to talk about domain-driven design, because like it have always like this data source concept, entities and stuff. But let's project what we need, at least for this upcoming concepts, okay? We have 4 main layers that we are interested in. We have the presentation. It's pretty easy to understand. We have the widgets, states, and events there, like events that come in are triggered by the user events or something like that, and also the states we need to react for the presentation layer in that case. If we are projecting like again block on into this one, okay. And then we have the application, really important. Here we have like the blocks of the business logic here. When it comes to state management solution, I think we have Reverpods test. We can do that here too. And it's more about like testing your real business logic here, okay? When we talk about test later there. The domains will encapsulate all of these, and it will also have entities. And when it comes to the infrastructure, we're talking about here about like anything that is external to our like core functionality or core application, okay? So this may be like an integration with your real backend. It can be an integration with, let's say, any third-party solution, or it can be as simple as the data source, okay, for your application, where I'm getting the data from, okay? I will refer from now on to the infrastructure with only the repositories, as in most of my solutions, I encapsulate the data sources like inside the repositories, okay? So from now on, when I talk about repositories, think about it as if it is like about data sources and also any third-party like solution I'm integrating in my products. Okay. Okay. Starting simple with the lowest layer, which is like the repository, where we have like any data source there, any third-party solution integrated there. What's cool about Flutter is it's really easy to create those kind of like hosted packages, I would say. So if I have an application, I generate it with Flutter Create. And also what I would do is I create a folder, which is packages. And then inside of it, I will create, let's say, I don't know, posts package, which will be responsible like maybe for any third-party integration related to that specific domain, okay? And this also can be any sort of encapsulation you can do there. And it's pretty easy. You can create a new folder, packages. Inside of it, I create, let's say, I'm integrating changelog functionality. So what I would do, I create a folder which is changelog, and then inside of it, I write Flutter Create, and I will choose like the package option when I create, and that's it. I have a package. It's really easy to manage. So I will really encourage using this kind of encapsulated package inside of a Flutter package. It's really easy to manage, and also maybe the only, I would say, trade-off there is if you have like a pipeline, you need to make sure that you test all those packages, because like you can't run the test from like the root project. But there are workarounds around that. I will talk about that in a bit. Okay. Let's keep it simple. We have a repository, which is encapsulating some sort of logic that I can like remove from like my core functionality or core application, okay? What I would do is I will fully cover that. So that will be a dependency for my project, but it will be fully covered, okay? So from now on, whenever I use it in any domain or in my core application, I will make sure, I'm sure that this is covered with tests. So I don't need to test it. I will mock it in that context, okay? Also, in this level, I will cover any helper if it's part of like this kind of, let's say, family of utilities, okay? Moving forward, we have the application level. And here, we are talking about the business logic or the features, let's say. This is mainly if you are using like blog, then you have a utility called blog test. Really straightforward to use, really easy to use. And it's the concept there is, hey, if I get an event from the user, this is what I expect. Okay, there will be a feature that will run there, like a business logic, like that will be treated there, and then I will expect this result. I don't care. I have this input. I expect this result, and you need to go through this feature and try to get me that result. Okay, this is how I cover my business test. But anyways, what I'm trying to say here, if you need to, wrap your business logic into these units, and it can be with blog or anything else, and then you need to cover them with unit tests. I think this level and also the repository level need to be as covered as possible. Okay, but we are testing, so there is always trade-offs and trade-offs. You need to do the trade-offs as carefully as possible, and then at this level, since I have my repositories fully covered, what I would do usually is I mock the repositories. Okay, so any third-party like integration, any API integration, I would mock it at this level, and they will be only focusing on like the business logic here. Okay, and in the case of using block, then I will do it using block test. Okay, in this case, I will, of course, depending on the suite test, you will start a given behavior. Okay, so if I'm, let's say, I don't know, like I'm using a repository that will authenticate me. So in that case, I will say if this is what's stopping about. When this action is called, then I expect this result, okay? And then I move forward with my test, okay? Now we have the infrastructure layer fully covered. We have the business logic covered. Now it will be all about like trade-offs, okay? Let me just double check time, and I think I still have quite some time. Let's move forward. Okay, moving to the presentation layer. Here I do a lot of trade-offs, okay? And these are like valid statements for my case, for my team, but it can be valid for I think most cases. Widget tester, after evaluation of WordPress, we are doing like a lot of visuals. Sometimes it's like you are using like a widget coming from material design straight away, so there is no sense of like testing that, because like it's out of the box, so it's not like a complex a logic that you put in there to be able to really have concerns about like how it goes there. So it's when it comes to widgets, it's more about trade-offs. You need to evaluate each case and see if it's really worth to go and test that piece of code. And then I think a lot of people are talking nowadays about golden tests. If you are coming like, I don't know, from like any other front-end solution, they are more commonly named as like snapshot tests, which is mainly, I don't know, it's more about like how the tree is now, like when you render an object or a widget or a component, if you are coming from React, how it is like converted, how it is rendered. Now, next time, if I change, let's say, a color or something, I need to double check that this didn't change, okay? So it's more about validating the UI. For me, I'm not a fan of it, and usually I don't use it because, especially like in the development process, the UI changes a lot. And if I'm always like invalidating my previous snapshots or my previous images, it would be like an overkill, at least in the development process. Maybe when we ship into, maybe if we are in the beta phase or in production, it makes more sense to have this kind of golden test there. Now, we covered our like all the dependencies. And we try to make, I don't know, everything that can be a dependency needs to be encapsulated in that context. And also we need to cover it as much as possible. And then we have the application level, which is the business logic. And we try to cover it also with either block tests, unit tests, or whatever solution you have in hand. And then we went to the visual aspect, and we tried to cover the complex widgets, I would say, and did some trade-offs there. The golden tests are optional. You can do them. If you don't want them, you can skip them. Now it's coming to a place where we have like the whole application there. We have all the layers. They are covered like in percentage. Let's say some are fully covered. Some have like some kind of trade-offs. Now let's test the whole application and see if our like business flows or our features are working really, like from a user perspective or from an end user perspective. Okay. Now I'm referring here to the integration tests. This is like about the terminology. Some people refer to integration tests as anything that you like. If you integrate any two units, that's integration tests. Okay, so if you integrate two widgets into one screen, then a screen is usually an integration test. If you are testing a whole screen, for me, I don't refer to that as integration test. I refer it to for me. Let me talk about E2E, then I will differentiate the integration test in this context. E2E means I have an application, maybe it's connected to like a third-party solution, like backend or something. I don't mock anything. So I have a user or a robot that will run through my application, fill in inputs, and then by the end, it will send the request to the real database. It should be like a staging database or a testing database in that case. And then I will validate use a test suite. Okay. When it comes to integration, it's this with mocked integrations. So we go back to the infrastructure layer, which is repositories, and they mock everything. And then I validate some features there. Okay. Just about the terminology. Okay. Now for your teams or like for your projects, I think most people pick between these kind of solutions. Either you do integration where you mock everything and you test like a specific feature, or you do E2E. Some teams do both. For me, I do a hybrid depending on the context. Let me explain. So let me give you this scenario, okay? So I'm trying to validate the login with phone, okay, or sign up with phone in most cases. If I'm signing up with phone, then what I try to do, I will provide the phone, and then I will send an SMS, okay, and then I will need to introduce that like code I got from the SMS or from the message, and then I will go to, let's maybe I don't know, the join-in flow, okay. For me, it's not worth it to try and do this and create an API that will fetch that code from the helper, I would say, from, let's say, if you are using Twilio, you use the REST API from Twilio to get that specific code in order to validate this flow. It's more of a complex UI flow than a feature flow. Like from like the backend perspective, it's pretty straightforward. So I would maybe validate how the flow goes from like a user perspective. This is where I use integration. So I mock the whole thing, and then I would make sure that if I move forward, then maybe if I validate like the timer or something like that, it's working. The timer is working. I introduce the code. I'm able to achieve this specific feature flow. Okay. If I'm doing something like that is really critical for my mission, which is maybe if I don't know, if I'm on Facebook posting like a post needs to be visible by a given user and he can't comment. Maybe this is the user flow. Here I use the E2E. Here, I think to achieve E2E is simple. You are running the app, use same API. If you are using the latest integration test package, then you will be able like to use the same API as for widget test, which is like the widget tester. Same API. So if you know how to do widget tests, you know how to do the integration test with E2E, okay? But when it comes to integration, I found myself like in, I don't know, hitting a block, because how would I like mock everything and make only like the core functionality and also my domains work? This is a bit of like a blocker. And how I did this is, sorry. So.
Carry on.
Yeah.
Start wrapping up though.
Yeah. Sorry. So what I do is I create always like a mirror of my main file. Okay. So in the main file, what I would do is I will use the repository pattern, and there I will provide every single dependency as a repository as if I'm using provider. If you are using block, then you have a repository provider out of the box, but you can use that like because it uses provider like underneath. So what you need to do is you need to provide in the main file every single dependency there, okay? Then what I would do is I create a mirror of my main. And in the mirror, what I would do, I will use Mockito or Mocktile, if you, wherever you need to choose there. And then what I would do is I would like mock every single repository there. Here is an example with only one repository, which is mock. This is a typo. It should be authentication repository without mock. Sorry for that. And then what I would do is I would create this mocked version, and then in the multi repository provider, I would provide the mock instead of the real repository. So if like from the root level I'm providing every single dependency, I would be able to create a mirror of that main, and instead of providing the real like dependencies, I would provide the mocked versions. Okay, I would be left like with only one problem, which is stabbing. So how can I say like for this specific test suite, I want for this use case when I execute a function, I want to mock this function. For that, I would provide like this new main I created with a callback that will take a set of stub callbacks. Okay. So what I'm saying here is this stub. What it will take is, let me see here. So as you can see, I did stub.call, and I provided an array of all the repositories I have as mocks, of course. And then what I do in the suite test is I call main mock, which is a mirror of my main And then what I would provide is this called stubbing. And for every single mock, in this case, I have only one, which is mock authentication repository. I would do the stubbing there. So if it is like an authentication repository, what I would do is when this mock is signing, then provide this access token. Okay, don't care about like this fake kernel email. This is our like helpers that they create in order to create those random files. So this is just the idea to be able to achieve this mocking of every single dependency in order to achieve this testing of some specific cases. Okay, I hope you got the idea. It's just about like mocking. Like the initial idea is to be able to retrieve everything that is like a dependency and provide in the root. Okay. Now, if you are able to do that, then you will be able to do this. Okay. Moving forward, when it comes to E2E, it's pretty simple. I think there is one blocker that you can think about here is if you are not testing like an application, but you are testing like a system, where you have like maybe an application, an application, and then a platform, let's say, dashboard, okay? And there are scenarios that you need to validate that includes both. This is maybe the blocker when it comes to E2E. For us, like we created like a helper, which is like a client specific for this one. So if I'm trying to, this is a simple scenario. So what I'm trying to do is, I have a user, given a user, I want to be able to sign in, okay? Now, what I would do is I call this helper. It will create the the user, like calling server directly with this utility, and then what I would do is I validate it as if this is created, because I'm creating it as part of my testing flow. Okay, this primitive .signup email and password can be anything from another like components of your system. So let's say you're creating like a post from like let's say a dashboard, and then you want the user to be able to comment in that like post. So what you do is you create this kind of utility. It creates the post, and then you can follow the E2E flow. Okay. Again, 1 minute or two, and we will be done. Okay.
They're acting.
Okay.
Closing the building. That's why.
So sorry about that. We have integration tests with mocks. I mock everything, and I validate things that I can do with E2E, but it's more convenient to test maybe the mobile side only in that case, okay? And I do E2E for almost every single feature. At least it's really important for like the critical ones, okay? I think I will skip this one, but you find this as part of like the slides. It's just about like the fact that with Flutter, it's really easy to integrate with Firebase Test Lab, and also Codemagic supports integration tests out of the box. So all of these needs to be really straightforward once you get this kind of gotchas. Okay. Thank you so much. If you can scan this one, you will find the slides there. Thank you so much.
Closing the so we can give away the questions.
Okay, yeah.
Everyone, can I just get your last attention? Tomorrow, if you go to the website, you'll find links to the spatial chat. We're going to do everything online tomorrow. We want to join everyone else online. There'll be dozens of people, maybe hundreds of people even, from around the world hopefully joining us. So check the website in the morning.
Thanks for coming today, guys.
Thank you.